So if you have any doubts or any questions, you can stop me at any point of time. So we'll start quickly. So shall we wait one more minute? So we'll start with the basics of the transport economics. So there are some different parameters we generally adopt when we are doing economic evaluations of the transport projects or any category of infrastructure projects in general. So let's see, the basic content will be the economic analysis of the highway improvement and the origins of the economic assessment and the basis for the economic evaluation. And what are the different methods of the economic analysis we have, and project evaluation, the decision making process. So these are the content we are going to discuss in this session. So just understand that. So if you doing a or adopting a economic evaluation of your project, what actually the general major steps we adopt. So first we'll start the any kind of economic analysis of your highway project or any related to the infrastructure project. So then for the highway specifically, so we have to do the forecasting of the traffic. So that means this project is not for the corresponding to the day what actually we have the origin year. Suppose if you are looking for the origin year, maybe like the 2025. So then you are expecting this project will be there up to the 2050. Then we are looking at how this project can be looked out at the 2050. So that means, so what is the current traffic we have, maybe 4,000 vehicles per hour. So that has to be understood. So then this 4,000 vehicle has to be forecasted for the 2050 case. What is going to be happens? So now corresponding to the 4,000 vehicle condition. So then what are the speeds we have, and what is the average speed we have, and what are the expected delays we have. So everything we know at 2050, 2025, that we are trying to forecast traffic. We are estimating that what are the speeds expected 2050. So that's what actually we have done. Even the yesterday example of the transport economic evaluation of the project of the based on the IRCSP 30. So then we correspond to that. We are going to look at the what is the kind of the highway design parameters we have, that we are going to adopt it. So apart from that, we are also looking that, so what are the different types of the factors will be impacting on the your design in terms of the highway design as well as the forecasting or the evaluation process. Then we have the different factors, that is the market factors, and we have the non-market factors. What it means that the market factors, suppose you are forecasting a traffic, then corresponding to that how the vehicle operating cost and the time value of the time is going to changes. So that's corresponding to that we are going to estimate the highway cost. So then according to that we are also looking at what is the road user cost. Then we are adopting a specific method of analysis at the economic evaluation. So then corresponding to that we are going to look at the how the economic evaluation or economic value to be estimated. Then finally those results will be synthesized as the report. So then finally we are going to look at the decision. And this is the one way is directly we can monitor, or the monitor values can be estimated in terms of the majorly in terms of the road user cost, or like the vehicle operating cost and the value of the time corresponding to that vehicle operating cost, as well as the generalized cost. Otherwise, what we have done in the yesterday class, that is generalized cost. Apart from that, so that is the one side of the coin, but the opposite side of the coin we can also look at that how the road user personal preferences will be there, and what is the socio-economic impact with respect to the improvement of any specific category of the road, or corresponding to the what are the road we are expected to design or they expected to improve. So then there is a chances that the land and the business economics can be happens with that. So then there is a community consequences can also be expected. Then that may be interlinked with respect to the public sector. So this analysis, whatever we going to get non-market factors to be linked with respect to your analysis, then when you are doing a management decisions or the specific highway decisions of corresponding to the project to be interlinked with respect to the non-market factors even. So any questions or any kind of points to be discussed here? Or shall I move? Okay. So then try to understand the horizon in the economic assessment. So any economic assessment usually carried for the specific time of the origin. So like if I'm looking for the general long-term projects, mostly it is more than 30 years generally. Sometimes if you are like the metro project or like other than that, like if you are going to construct a major projects, mostly it is about the kind of 50 years even. So even though it is very true that actually the periodical assessment corresponding to the maintenance cost, corresponding to the routine periodical, all the cost has to be incurred into the project. And but what happens actually at the end of the project, even if you have kept everything together, but their project will be retained to you, so that maybe like your salvage or like the what generally we call as the residual value of the project. So this residual value to be identified when you are going to modifying or the redesigning or the relooking of the project actually. So that means that value will be added to the project cost, so that okay, this is the kind of additional value we have already corresponding to the project of any selected project. So this value will be changes respective to the project or the condition of the project even. So there are several other factors that has to be included into that. So then when you are taking about the discounting process, so this value has to be completely subtracted from the actual value of the cost of project. Because actual cost of the project, let us assume the 100 crores, then you already have the residual value of the 10 crores, then actual cost of the project can be incurred as the 990 crores. So that's the way generally the project will be look like. So then we have the different types of the. Oh yes, any questions? The slides are not moving. Okay. Okay, let me check the. Let me reshare it. Maybe problem with the my screen. Can somebody confirm? Is it moving now?
Yes.
Okay. So there are different types of the discount rates we have or the interest rates we have. Then corresponding to these interest rates are the way the economic evaluations will be carried out. So then based on that, so then the interest rates will be changes, and that maybe again depends on the project to the project, and the corresponding to the bank interest or maybe like the corresponding to the lending of the different value of the projects. So let's start the what is the rate of interest? It is the money paid to the borrower for the use of the money loaned to him or like loan to any specific category of the project. It is also generally called as the maybe what is the discount rate or interest rate generally of a specific project corresponding to the borrower side. So if you are taking a government bank, that interest will be different. If you are taking from the private banks, that might be different. If you are going for the international banks, so those interest rates will be different. So again, apart from that, so it is also varies from the project to the project. So then we have the return or the rate of return. So that may be indicating the monetary net return received from operating of the enterprise of the entire project. So then there is a kind of sometimes what happens actually when you are operating a project, so there is a depreciations will be added into the project. So year on year the depreciations cost will be increases, then the value of the project at certain period of the time will be loss corresponding to the total depreciation will be taken into the account. So that is the actually the rate of return, how amount will be getting at end of the period or the corresponding to the horizon period of the project. So then we have the West charge. So that is a charge for the use of money invested into the physical assets. Actually, like if you are selling a bonds or like the selling a land, something like land bond, something like. So then, what is the total amount of the money you are investing with respect to those categories? Actually, so maybe like if you have the road construction is done by the government, so the government investing the money, but the gains not getting directly to the government. It is all about the public gains in terms of the social economic development of the project. So there may be sometimes monetary terms. So that may be like your market values, what we have seen here. So these monetary terms or market values corresponding to the road user cost, or maybe like benefit in terms of the vehicle operating cost. So that we generally take into the considerations with respect to the each project have the different monetary terms or the different market values actually. So like we have the different types of the terminologies or generally the interest rates we'll adopt. So of course, like these are like very basics we have already studied, maybe like at +2 or plus 10, probably around 10th or around we have all the different types of interest rates you might have seen. But just kind of recalling what generally we'll adopt into our economic evaluation process. Like if you have the money at present as 100 rupees, even Professor Vinayak has already discussed this point. It is easy for me to catch up you like how to interpret these values. Like if you have 100 rupees and after 50 years, what is this value of the 100 rupees? So that I'm looking at maybe after 1 year instead of 50 years, after 1 year. So I'm taking that the 10% interest rate. So then I can see that, okay, there is a 110 rupees will be added at the end of the 1 year. So like that, if you have the cumulatively 10 years, so then how much amount of the money to be added into that? So that's the way we are trying to understand that the amount of the S to which rupees of the one will increases in n years with the compound interest rate of the R. So that means if you are taking a compound interest rate of the 10% and corresponding to the 10 years, what is the value of the 1 rupee at present corresponding to the 10 years? Suppose instead of that, so suppose you want to have the 1000 rupees now, then how many years will be taking if you are investing a something like 100 rupees, something like that. So that also can be added, or maybe like you can also reverse this. What is the present value of the A in the n years with respect to the discount rate of the interest is R. Suppose if I'm taking that, okay, if you want to get a 1000 rupees now, so how much amount of the time it will be invested and how much amount of the money will be invested? Let us assume the time will be fixed as the 10 years. So if you want to get the 1000 rupees now, so how much amount of the money to be invested for the 10 years? The same way that we have the present value of the A, the annuity will be added as a 1 rupee per year. For n years, the discount of the corresponding to R. So then it can be given as 1 minus of 1 plus R to the power of minus n divided by n. Like we have the several ways to understand that how this money value will be going to changes corresponding to the interest rates, that is our discount rate otherwise, or R, corresponding to the duration of the time, that is n years. Because it is important that so our project cost a worth of 100 crores, we need to understand that if you are investing 100 crores, what is the value of this 100 crores at the 50 years are corresponding to the getting of the maximum benefit of something else, some amount, some x amount, what you are actually to be invested now and what rate to be invested. So that might be your discount rate of the R and corresponding to the money how much you want to get at the after maybe 10 years, 20 years, 50 years, like that. So there are several ways to understand the discount conditions, a discount rate of interest corresponding to the number of years you want to be invested. So this is the way.
Sir, sir, one query I have. This formula is standard or it is varies from the agency to agency?
Yeah, as we discussed already, it varies respect to the bank to bank or like the different borrowers actually, like the not borrowers, so different who are going to sell or like they give the your money as
Okay.
per the discount rate. Suppose if I'm going for the general national banks, so at present is currently 6 to 7 or like 7 to 8% actually. But if I'm going for the international banks like ADB or like the World Bank, so then this discount rate will be different. And the money what we are actually invested to the project is also different corresponding to that. Suppose if you have the cost of the project is only below 50 crores, something like that, so mostly we'll go directly to the local banks mostly. But if you have the cost of the 3000 crores or like 5000 crores, so it is not possible for them. So sometimes it is also possible that there are different types of the banks involved together, At the same time, there are different discount rates will be involved into that. Like sometimes some money you are borrowing from the local banks, and some amount of the money you are borrowing from the ADB or like the Japan or like other banks. So then the discount rates corresponding to each bank will be different.
Okay, sir. Got it. Thank you.
So the same way, so the amount P per annum if you are investing, so for n years if you are doing that with respect to the interest rate of the R, it need to be accumulated. So with respect to the P is equal to R divided by 1 plus R to the power of n minus 1. The same way it is generally called as the, okay, you want to accumulate some amount of the fund with respect to the total amount of the money as the P with the interest rate of the R and corresponding to the n years. So then what is the total amount of money will be accumulated? So that we generally call as a sinking fund. Then we have the same way the capital recovery. Suppose you want to make the sinking fund as the R divided by 1 plus R to the power of n minus 1. If I'm taking that is the sinking fund, then corresponding to that, what is the growth you are keeping with respect to your invested fund? That is the your 1 plus R to the power of n. That is your this S value actually. So that is the way this value we generally call as the capital recovery factor. So then we have the present worth factor also the same way. So whatever the money you are investing, that is corresponding to this 1 minus, sorry, 1 plus R to the power of n minus 1. So divided by R into the 1 plus R to the power of n. That is the what is the total amount of the uniform payment of the money. Like I'm keeping every year 1,000 rupees. Then corresponding to my keeping of every accumulated money of the sinking fund, that is the R divided by 1 to the power of 1 plus R to the power of n minus 1. So then what is the total amount of the money will be looked at the nth year? That is the total present worth factor actually. Like we have the different values corresponding to the different method of academic evaluation we have to use. Like if you just look into the IRCSP 30 2019, what I have shared already with you. So there are different types of the equation they have given. So that is given P value to find the F value, then we generally call it the compound amount value. So that is the 1 plus I to the power of n. So if you have the what is the total amount of the money you have, so then you want to estimate like the what is this money value in the future year. That will be 1 plus I to the power of n, that we are considering as the compound amount actually. The same way, so if you have the given F value, if you want to find the P, so that is okay, you have the 1,000 crores for the future year. What is the money to be invested now? That is the P is equal to F by 1 plus I to the power of n. Like we have the different ways to identify or understand that how you are going to invest your money into the project and how this money can be looked into corresponding to the different interest rate and corresponding to the different accumulation rates and corresponding to the maybe like the fund will be considered as a sinking fund, or the fund will be considered the present worth corresponding to the future case. So these are the ways we generally looking into the different interest rates or like the compound interest rates equations. So now we will start with respect to the method of economic analysis. So generally in the economic analysis, the cost is invested. So that is the initial investment we have, then corresponding to the maintenance cost we have, then the operational cost we have. The initial investment is always treated with respect to the what is the total amount of the construction cost. So when I'm breaking the total construction cost, it is already the cost related to the materials, equipment, land, and everything. Apart from that, the taxation system, what we have incurred into the project when you are borrowing some kind of the equipment from the different countries. And apart from that, the borrowing of the material from the different taxation policies again. Like there are different types of the cost will be involved into the construction. So that put together, that is your initial investment of the project. Apart from that, I'm going to look at every year what is the cost to be incurred. So that maybe like the 1,000 crores, I'm keeping the cost of the initial construction. So every year I'm keeping the 2 crores that might be maintenance cost. Then apart from that, okay, I'm going to operate a signals or operating in terms of the different operational system of the road, or maybe like the toll. So put together, that is maybe like your operational cost. So then consider these all. So then we might be achieving as some kind of the societal benefits or like the socio-economic development of the project. So that can be treated as the benefits to the user actually. So there may be direct benefits, there may be indirect benefits. If I'm taking as a direct benefit, so okay, if I'm investing 1,000 crores, then how the vehicle operating cost has changed, or the value of the time corresponding to that. are corresponding to the different conditions of the road, then how the vehicle operating cost has changed after implementation of the modification of the project and before implementation of the project. So now if you are subtracting, that can be looked at, okay, this is the kind of improvement of the project has been achieved. So that can be treated as a total amount as the benefit value. So there are different methods we have to understand it. So then we have the rate of return methods, then we have the discounted cash flows. So that's the reason corresponding to the rate of return or corresponding to the discounted cash flows, we have the several formulas respective to the discounting or respective to the what is the rate you are getting the returns of the project like that. So in the rate of return, so we have the methods like the benefit cost ratio method, we have the first year rate of return method, then we have the equivalent uniform annual rate of return method. In the discounted, we have the net present value, internal rate of return, and the equivalent uniform annual cost. So let's start with respect to the first method, that is the benefit cost ratio method. So according to this method, so we are going to estimate the benefits of all the we are expecting from the project divided by what is the total cost of the project. That is very simple formula we have. So this ratios the road user cost of existing road minus the road user cost of the improved road divided by equivalent annual highway cost improved minus existing. So can you expect what are the points will be involved into the road user cost of the existing road? Yesterday we already completed this point actually. So that is your vehicle operating cost. So what is the vehicle operating cost of the existing road? What happens actually? Let us assume you have the 4-lane divided roadway. So it is expected that this road has to be maintained, but you have not maintained properly. So that means, so this is the direction of the traffic in one side and this is the direction of the traffic on other side. So then if I'm looking at, so the vehicle operating cost of the current condition of the road might increase like anything because the speeds will be dropped down. So then the vehicle parts or the maintenance to the vehicles in terms of the fuel consumption or in terms of the grease or like the maintenance of the different parts of the vehicle, everything will be goes. One way the speed is getting dropped and the other parts of the vehicle components will be increasing, then the total vehicle operating cost will be increases. So then the road is after improvement, so then there is a very less amount of the cost will be involved, so that the vehicle operating cost will be decreases drastically. So then we have the equivalent annual highway cost improved, what is the total you kept and what is the actual existing case. So then if you subtract, that is the total cost you are getting. So then on the numerator we are getting the total benefit, so now we are taking as the ratios. So can you expect what is the value should be b by c, whether it should be less than 1, whether it should be equal to 1, or whether it should be more than 1, when it will be easy or when it will be okay for us? Any thought process or any ideas, any points to be discussed there? Hello?
Yes, sir.
Yeah. So can anyone can expect that what would be the b by c ratio value if I want to implement this project, is worthwhile to implement or not? So if you want to implement this project or if you want to consider for the implementation, the b by c ratio should be greater than 1 generally. If it is more than 1, so this project is worthwhile to invest. Otherwise, so it is not feasible generally. So the b by c is less than 1, alternate is not at all viable. So b by c is equal to 1 is the feasible case, b by c is greater than 1, so it is the best alternative. Of course, there is a kind of points to be understand when this method is easy to apply. Of course, this method is very easy to apply, but when it can be applied. So b by c method can consider the changes in the benefits and the cost that would be caused potentially with respect to the implementation or improvement of the project, whether or not the project should be undertaken at all. So okay, if you are not taking off all the conditions of the project into the case, okay, this method cannot be directly implementable and we can't expect the benefits what we are trying to expect it actually. And the b by c ratio method may reveal that the project does not pass economic muster now. So that means okay, even if you get the b by c ratio is more than 1, It does not mean that okay, this project is ready to take up actually. So there is still we have to do further economic evaluation with respect to the different methods, because sometimes what happens actually, so the benefits will be looked at very high way compared to the cost actually. So okay, sometimes okay, the benefits what we are expecting as the social economic benefits or social economic development, sometimes it might not be achieved fully after some period of the time. So then there is a loss of the project will be there again. So that's the reason the B/C ratio alone cannot be treated. But if you have the similar categories of the project and the similar conditions and the similar in terms of the cost, that is the best case to take up this method. So that means like you have the very similar case of the project and the same very similar case of the cost. The new denominator is very like similar or very closer to equal. So in such cases, this B/C method is the best choice compared to any other method. So this is the general process we have for the when you are looking this B/C ratio method. So establish the objectives, identify the constraints and the specific assumptions, and define the base case and identify the alternatives corresponding to that. So what are the different alternatives you are looking, and each alternative has a different cost actually. So that means these alternatives directly cannot be compared with respect to your B/C ratio alone. But alternative 1 versus the alternative 2 we compared with respect to their benefits generally. Of course, the cost at the denominator is different. There is no doubt on that. But still, the benefits need to be looked at. And the analysis period generally it varies respective to the project. Sometimes some of the projects might be like the major. Sometimes some of the projects like the minor cases, like 5-10 years or like 15 years even. But major projects, if you have the equal in terms of the project cost as well as the project, then this B/C can be adopted. So define the level of efforts for the screening of the alternatives and also analyze the traffic effects. So what are the different types of impacts to be there on the project, and estimate the benefits and the costs relative to the base case. So what is the actual base case and what are the different alternatives you are setting up. So then we need to look at the risks and the compare the total net benefits and the rank all the alternatives. So this is the way generally the major steps will be adopted in the BBC method. So then we are moving on to the next method, that is the first year rate of return method. So in this method, the benefits occurring in the first year will be taken into the account. But what happens actually, if you are taking only the first year benefits, sometimes after a few years, like the first 3 years, the projects will works very well. So the best example for this actually, like you have the very high volume of the intersections. Now you thought of okay, we are going to provide a kind of flyovers to minimize all the kind of the delays what we have at this junction. So then you constructed a flyover, then you after construction of the flyover, so then you this project is working very nicely after up to maybe 3-5 years. So this 3-5 years there is no delays, nothing has happened, so then everything is going fine. But because of this constructing flyover, so there is a more attracted traffic is there, so all the traffic from the different routes it is attracted. So then obviously what are the congestion you have at the initial, so the congestion has increased drastically. So then obviously what are the delays you have previously, the same delays you might be having after few years, maybe within 2 to 3 like 2 to 5 years. Then what are the money you have invested to make this flyover, so then there is not worthwhile, because this is flyover is not for the like minor project, or it is not for the very short period of time. So that's the reason. So this first year rate of return, so some cases it is useful, no doubt on that, but many times it may be fails if you are unable to predict that this project will be what going to be happen after few years of the uh, construction or the open of the project. So that is the benefits occurring in the first year will be taken and the capital cost to be compared. So then that is your first year rate of return method. Then we have the NPV value method, that is the net present value method, what we have already discussed in the yesterday example. So this net present value, that is the present worth method, is based on the discounted cash flows techniques. So in this method, the stream flow of the costs and the benefits are associated with the project over an extended period of the time has to be estimated to given current value or the present values. The benefits are treated as the positives mostly, while the costs are treated as the negatives. Then when you are doing a B minus C, that is the benefits minus cost, then we are expecting as a cumulative positive value. Then this net present value, if you have the highest cumulative positive value, that means the project is worthwhile to invest. So in comparing more than one project, so a project with the highest net present value should be accepted. So which means that if you have the more detailed way of understanding of your first year rate of return values, then you have the BYC, then you take again the first year rate net present value method, then try to understand that the cumulative value of the benefits respective to the different period of the times, that is extended period of the time, to be given corresponding to the present value. So then what is the total amount of the cumulative value of the benefits? Then these benefit value is highest as positive, then this value or the project can be acceptable for the implementation. So that is the viability of the project can be there. So generally the present value, net present value to be estimated in the following formula. So like NPV is equal to B naught minus C naught, that is the origin year, what are the benefits and what are the cost. Mostly if you look at that origin year, so not the first year, origin year means maybe like the base case, it is very difficult to expect any kind of the benefits from the project. Okay, so then after first year, so then because immediately after opening of the project, I'm not expecting any kind of benefit in terms of the improvement of the vehicle operating cost until unless it is completing at least a year. So then from the first year onwards, respective to the discount rate, then we are seeing that what is the kind of total benefit by giving discount rate of the I corresponding to present values. The same way I'm going to look at for the second year and so up to nth year. Then I'm going to find out what is the total cumulated value of the net present value. So you have any questions till this slide? Hello?
So how much time we will consider? Means after 2 years or 3 years, or it is depend on the road condition, which type of road we have designed.
Generally, it depends on the project type to project type. So mostly if you are taking the horizon year of the project as the major case, maybe we generally go for the 30 years generally.
Okay. Got it.
Any other questions? So, okay, we are moving on to the next method, that is the internal rate of return method. So this internal rate of return is the discount rate which makes the discount rate for the future benefits. Okay, suppose I'm having the total value of the money for the future case is the 1000 crores. Then what is the discount to be taken out to get this 1000 crores to be reached? So that generally treated as, suppose if I'm eliminating the initial value respective to the B naught minus C naught. So then if I'm adding that, this is the discounted values for each case of the present value corresponding to the future case. So that is B1 minus C1 by 1 plus I. So then I'm just left the NPV method of B naught minus C naught. The remaining thing will be same. So that is the only difference we could observe between your IRR value to your NP value. So that means, in other words, the discount rate which makes the stream of the cash flows to the zero. So now if you want to make the zero, so then you are equal to the NPV value. So that is the internal rate of return is the discount rate that makes the net present value of all the cash flows for a particular period equal to the zero. So what is that period? So whatever the horizon period you are considering for the project, that may be like your 30 years. So then you are equal to the corresponding to all the discount rates for the 30 years equal to the zero. Then you will get your total IRR value. So mostly many projects, the IRR will be looked at very seriously. If the IRR is satisfying, so mostly the project is viable too for the implementation, because it is relying on that not only the corresponding to the your first year, second year, third year, it is the cumulative value of the discounted respective to your all the future year cases. Plus, then we are also trying to look at that we are not considering any case of the base year section, because the base year is completely eliminated. So then obviously we are expecting that, okay, what is the benefits for each and every year correspond to the given discount rate of the I, or like your R. Suppose sometimes some formulas may be using R most of the time, so we can generally adopt that what is the actual discount rate. So maybe it is 10% or 12% or 16%, and corresponding to that, what is the total amount of the money is worthwhile, or maybe like the what is the value of the present value of the money corresponding to the discounts. So numerator we already have the what is the total benefits minus the cost. So then if you add put together, so then you will get the some number. So this mostly if you have the positive number, so then obviously these projects will be worthwhile to invest. But sometimes what happen actually, so if the project is not viable, like what we have seen in the previous example of like flyover, so after few years, like first year, second year, you have the highest benefits, but the third or fourth year onwards, you have the mostly as the negative values. But when you're added together, t is equal to first year to the your selected 30 years, then you have mostly as the negative values, then obviously this project is cannot be taken into the account. So that's the reason. So the internal rate of return method is the mostly adopted method for the any economic evaluation process. So if you see any document for the economic evaluation of the projects, the IRR is must be there in the calculation process. But still we have some issues. What you said, like Manish has already pointed that different agencies have the different cash flows, or maybe like, sorry, different discount rates. Then obviously that maybe make some kind of the complexity actually. Okay, how I need to calculate IRR? Shall I go with the IRR values respected to the one lender, or maybe like the respected to the one borrower itself, or I need to take with respect to the cumulative values of the all the borrowers? But it is all again depends on that what is the money you have taken from this each and every borrowers actually. Apart from that, you have the different discount rates, but sometimes the viability of the project cannot be treated as the single discount rate at the single time at the origin period, because at the origin period you might be having the 10%. Sometimes this discount rate might changes respect to the bank policies, or generally the reserve bank will release the different interest rates at the different period of the times. Okay, then obviously this project sometimes be viable respected to the origin, but it cannot be viable after some time. So there are different types of complexities are there. So there is no, not necessarily the unique IRR is giving the situations. If there are several reasonable values which should be selected, and the low investment, the short term alternatives like the maintenance projects almost always give a relatively very high IRR values, because the very these are the very short term projects. So what happens actually, so I'm not looking as the maybe after third year. So after third year onwards, the negatives will be there actually. But till third year, you have the only positives. When I'm looking at the short-term projects of the 5 years, or like the 3 years, or maybe like within 10 years mostly, then you have the highest benefits actually. So then according to that, so then you have the maximum IRR value. So then those kind of projects cannot be looked into for the IRR case. So the alternatives with the highest IRR may not be have the greatest NPV at the proper discount rates. So even if you look at that, so when I'm equating the NPV with the IRR, so we are eliminated the B naught minus C naught value in the NPV. So even there is no chance that you have the same or the highest greatest of the IRR will be having the equivalent value of your NPV what we have estimated. So these are the some of the issues we already have with the IRR. So let's make some kind of the comparison between these methods. So then you will get the more clarity and idea which method is mostly adopted or which method is mostly feasible for us. So the benefit cost ratio method requires an assumptions of the rate of interest. So it should be to the extent possible related to the opportunity cost of the capital. So the opportunity of the capital is indicating that okay, you have taken a borrowing your money from the one bank. So then you got the interest rate of the, let us say, 6.5%. So then you don't know that actually. So there is a, if you are going for the highest amount, so then there is another bank might be giving at the 6 itself. So then you're making the loss of opportunity in terms of the 0.5 percentage when you're looking at the single bank alone. So that's the reason most of the time. So several the horizon year, if it is exceeding the 30 years and the cost is exceeding generally 3,000 crores, something like that, the we generally go with the different banks to avail the money actually. Of course, the single bank cannot be given even 3,000 crores alone. So that's the another reason actually. So, but we generally look at that what are the opportunities we have to avail the different discounts actually of the project. So the opportunity cost of the capital is very often not known or can be estimated only approximately, because if you are going only to banks of the known to you, then obviously you are losing the opportunity cost with respect to the other banks of the discounts. Again, the first year rate of return method is quick to use, again like the B by C, but it can be obviously shortcomings because more like the attractive benefits can be seen initially than compared to the other periods actually. And that the net present value method is also suffers from the disadvantage of the discount rates. So mostly all the methods have the discount rate method or discount rate using in their formulas, then obviously there is a shortcomings respective to these methods. So the internal rate of return methods avoids the necessity of the selecting of the discount rate initially, but obviously it is also cumulative values will be corresponding to the your internal rate of return method also. So the rate which is derived of the result of the computations can be compared with respect to the market rate of interest. Sometimes the market rate of interest is always different with respect to what actually you adopted as the discount rates. So then, so all these methods have the different variations in terms of estimation process, or like the computational in terms of the discount rates. So then obviously there are different types of the advantages or the disadvantages are there for each method, but mostly we generally adopt the IRR method. So then how to take a decision process with respect to this method of economic evaluation. So let's start understanding that you have done a economic evaluation is carried out to determine most realistic solution for the number of alternatives. Like these alternatives like start from the do nothing to the or like null alternative to the, there are several other alternatives we have, like what we have seen in the yesterday, like you have the four different alternatives. One is the do nothing case, then the alternative one is the improvement with respect to the widening of the roads, then the third option you have the improvement with respect to the widening of the road with the next 10 years. So then the improvement, the widening of the roads are making a four-lane divided roadway currently or present itself. Like these are the kind of different alternatives we have, and you compare these alternatives one versus the others respective to the different economic evaluation process. Then you made that all these alternatives you made as a ranking. So then corresponding to the best alternative or more attractive benefits, that might be the your topmost rank alternative or rank one alternative. So, but the economic evaluation of the alternatives mostly it is appropriate for the several principles. So that is the, we need to set the alternatives being considered should be included as the do nothing case with respect to the baseline alternative. Then we are making a pair of alternative comparisons. Then each alternative we are trying to look at the same method of comparison of the economic evaluation, because you can't look at that alternative one will be evaluated or done with the some way of the method of economic evaluation, and the alternative two you have done the some way of the economic analysis method or economic evaluation method, then you should not compare it actually. So sometimes when you're doing this process actually, again there's a kind of problem. So some projects might be having the subsidies and some projects might not be having any kind of subsidy, because some of the alternatives, so there might be chances that you might be having some kind of subsidies. So because when you are looking for the just improvement of the project in terms of the like the strengthening, so then you don't have any kind of subsidy actually. But when you are constructing a new lane or widening of the road with respect to the four lane divided roadway, then obviously you might be having some kind of subsidy into the project. So this subsidy may be in terms of the materials, or the subsidy in terms of the taxes and policies, and the subsidy in terms of the maybe like land acquisition process, maybe something like that. So then obviously there is a subsidy involved into the project, cannot be directly compared or cannot be taken into the account when you are doing alternative comparison. So these are the some of the what you call like we have the difficulties when you're doing this kind of economic evaluation process actually. So that is all about this economic analysis methods what we have discussed. So if you have any questions we will discuss, otherwise we will quickly start the next presentation. So any points to be discussed?
Sir, is there is any example for this all this method we have?
Actually, that's the reason I have shared this IRCSP
Okay,
30. So
okay,
there is a very detailed example they have given with the numerical numbers and everything.
okay.
And apart from that, even Professor Vinayak has discussed already this method with respect to the comparison between the two methods actually yesterday itself with the Excel sheet.
Sorry, sir, but that Excel sheet is not shared with us.
Yeah, yeah, we'll share actually. I just received morning only. I will share
Okay,
by afternoon.
okay, sir.
So only the main takeaway from this slide is actually, or these slides are like, if you have the several ways of doing of academic evaluation, but you might be resulting of the different benefits respective to the each method of the alternatives, or respective to the different methods of the academic evaluation and corresponding to the different alternatives. But the point is how we are going to choose that, okay, this is the best alternative. So that is the one of the biggest hurdle, because until unless if you are not involved completely in the academic evaluation process, then it may be looking as simple as actually, but it's not that simple, because each project have the different kind of benefits can be expected. At the same time, these benefits will be treated as different with respect to the total cost of the project incurred. But when you are considering the cost of the project, but this cost cannot be treated only with respect to the total initial construction or like maintenance, rehabilitation, or something, or like periodical maintenance or routine maintenance like that. So there are some costs which will be not directly shown into the project, but this cost will be also impacting respective to the what actually discounted respective to the taxation policy or some other thing. So these has to be addressed when you're comparing the alternative one versus the two, or one versus the three, or two versus the three, something like that. So any questions if we have, then we'll discuss. Otherwise, we will start quickly the next presentation. The externalities from the transport project. Any questions?
No, sir.
Okay, then we'll move on to the hopefully my slides are visible. Please confirm.
Yes,
And is it moving, these slides?
yes, sir.
Okay. Just give me 2 minutes break. Let me take some water. And I want to reshare the presentation. Actually, there is a modified presentation I have because some slides are not. Shortly share after the session. So please confirm. So my slides are visible. Hello.
Yes,
Yeah,
sir. It
visible,
is
sir. Visible.
visible.
Okay. Okay. So we'll start. What is this transport costs first and externalities? Or first we'll start what is actually this externality meaning, and what are the different types of the transport costs we have when you are estimating these externalities generally. So start generally directly with the what actually is externality. So when you are having the project, so there are some kind of positive externalities and the negative externalities can be expected. So let us take a kind of road you are expected to make an improvement. So just for the basic understanding, so we need to have, okay, this is the kind of 4-lane divided roadway. So there are 2 lanes on either sides. So what expecting we have, so this project is going to make 4 lane to the maybe 6 lane. So then I am going to add one more lane on the either side of the road. So because of this 6 lane, so earlier you have the when you have the 4 lane, so then you have the 80 kmph probably, or maybe like the 60 kmph instead of 80. So then I will better to 60. So then you have the 6-lane road. So then you have the speed maybe expected as maybe like 100 kmph. So then obviously what expected actually, so because the vehicle operating cost respective to change of the speed from 60 to 100, so there is a improvement of the 40 kmph. Obviously the speed flow relations what we have seen yesterday example, then there is a lot of improvement, there is a vehicle operating cost will be get reduces actually. So because reduction of the vehicle operating cost, so then if you are taking a benefits out of this project, so there is a lot of benefits in terms of savings of travel time. So this can be treated as the positive externality of the project. There is improvement of the vehicle operating cost, there is improvement of the travel time, there is improvement of the speeds, all can be treated as the benefits. But what is the kind of negative from that? Because once the project has implemented, so currently you have the 60 kmph, then it is expected to the 100 kmph. So now currently there is only 4,000 vehicles are moving on 4-lane divided roadway. It is expected, so there may be expected to move 8,000 vehicles or maybe 6,000 vehicles. At least you are adding on the network additional 2,000 vehicles. Because of this additional 2,000 vehicles, so it is expected more amount of the environmental damage. So that means the environmental damage is more and more. So that may be causes there is a more pollution, but there is a additional vehicles on the network. Each and every vehicle also getting increases the delay to the other vehicle sometimes when the project is reaches to the capacity. And apart from that, these additional vehicles are adding more and more environmental damage to the society, because you are not using the vehicle, because let us assume that your home is very close to the your road, this particular road. So then these persons are not accessing, because this is a, let us assume as access control. But what are the vehicles are actually moving, due to that vehicles, then the damage created by these vehicles will be causing as a negative impact respect to the residents of those closer to the road. Apart from that, there is noise, vibrations, all these will be giving as a negative externalities. So now we can easily understand any project if we have implemented, so that might be having a positive externality as well as a negative externality. Let's start the discussion respective to the theory. These externalities occurs when the production or the consumption of a good, or like adding of a vehicle onto the network, affect the third parties who are not using, or maybe who are using that particular category of the road or like network. So that is not directly involved to the transactions, or not directly involved into the using of the road particularly. That effect of an economic activity that is not incorporated into the reflected in the market price, that may be called as the externality. So what cannot be impacted directly? So we are directly looking what is the change of vehicle operating cost. So that is directly accounted cost respected to the project. So that's the reason we are estimating as a benefit. But what we have not accounted, we have not accounted sometimes, okay, what, how the travel times might be changing respect to that. So that may be your positive externality. So what is the change of the air pollution or environmental damage corresponding to the project, that is also not accounted, that may be your negative externalities. So the externality can be treated what is not incorporated into the or reflected from the market corresponding to the adding of a vehicle into the network respect to the market prices. These externalities, if negative, it may be imposes a cost is unaccounted for the private cost. That is the maybe they have given some example like the fishermen and the social cost for the smoke. Like if you are smoking, then you are adding the more and more pollution. So that not accounted that corresponding to the what amount of the pollution you are generating. For the private vehicles point of view, you are adding a vehicle into the network day by day or year on year. So more and more vehicles are passing on a specific network or like the road category, and whatever the kind of pollution you are making or kind of vibrations you are generating or noise you are generating, that is completely unaccounted. So that is the your negative aspect. And the externality if positive gives rise to a benefit not accounted for. But okay, you might be reducing the travel time, but you are not trying to directly accounting that actually. Okay. So the pollution is the negative externality, development of an area due to the industrial or like the development of a network, development of a new project as the transportation side. The result is that the cost or the benefits either the overestimated sometimes or maybe sometimes underestimated. So then that might be causing that okay, there is a chances that there is a more and more negative or sometimes more and more positive of the projects. So this negative externalities imposed to the cost on others, like the air pollution, the factories emitted the pollutant, harm the nearby community. The same way, you're adding the more vehicles to the road. So these vehicles are damaging the road or in terms of the air pollution, and who are actually residing of those communities will be having impacted in that. In the traffic congestion, that is one person driving delays everyone else on the road corresponding to the adding of additional vehicles. Like you have the capacity, so let us assume that you have the road. So then this road have the capacity of the 4,000 vehicles. Then the additional value of the one vehicle into the network, maybe like the 100 vehicles into the network, like 4,100 vehicles. So that may be impacting respective to that. Okay, so there is a additional 100 vehicles are added into the road network, and this 100 vehicles causes a delay of the maybe 100 seconds. So that is a 1.40 like 1 minute 40 seconds, and this 1 minute 40 seconds will be causing for every vehicle, not only this 100 vehicles. So it is causing to the all these 4,100 vehicles. That may be indicating that a additional vehicle on the network may be incurred a additional delay, which will be impacting to everyone. So the noise pollution, that is the construction of the noise, like the construction activities, are even corresponding to the adding of the vehicle that may be creating a noise. So then the negative externalities lead to the inefficient of the resolution corresponding to the allocated fund what we have to the project. So then there are different types of the solutions. Either we need to make them the taxes to the people, or polluters who are actually making a more pollution, are regulations in terms of the making a kind of congestion pricing policy as a regulation, or maybe like we need to make them in the different way to address this. Okay, if you want to use this particular category of the road which is very closer to the residential places, then you have to use a electric vehicle. So this is kind of the different permits, regulations, taxes has to be implemented to address this negative externalities. The same way we have the positive externalities. These positive externalities are the benefits to the are coming out of the from the project. It can be occur when the consumption or the production of a good or maybe like the service like the vehicle using a kind of road network causes a benefit to the third party. So how it can be, because you are making a new project, so that may be adding into the reducing of the travel time. So because when I'm using as a third party person, so because you made a road, but this road makes that, so okay, there is a reduction of my travel time when I'm using as a third person. So because I'm not relevant to this location, or maybe I'm coming from the other city probably, so then I'm using this network, so then I'm reducing my travel time. So then because even I'm adding a vehicle onto the network, but my reduced travel time makes me happy to use this road. So that is the case, like when there is an increasing in the travel corresponding to the speeds, you get saved a journey time, and not only yourself, it is also contribute to the other commuters, because the additional travel times respected to the increasing of the or maybe reduction of the travel time by increasing of the speeds makes you as well as your co-fellows of the travelers will be makes more happy. The same way they have different ways of example they have given, but what kind of solutions can be given? Okay, you make the subsidies. So how the subsidies will help? Like let us assume that you have a congested road. So then what I'm trying to do, so on the congested road, I make a HOV lines, like the high occupancy vehicle lanes, like the bus only line. So I'm making them bus only line. So then this bus only line, what happens actually? So when this bus only lines makes that the people can easily go and without any type of the congestion. But other lanes, only car people are there. So then these people have the more congested, because what happens actually, these car people will try to make use of the bus. There is shift of the modes will be there. Because of the shift of the modes, when you are using this bus, then you are reducing some amount of the cars on the other lanes. Then you are increasing some demands to the public bus because of the subsidies. Then because you are changing of the mode makes there is a decreasing of the travel times for the others. That is encouraging of the activities with the positive spillover to the effects. So that we generally call it the, okay, there is a positive externality of the project. Any questions till this point? So I hope you got some idea what is the externality meaning and what is meaning by negative externalities, what is meant by the positive externalities like. Hello?
Yes, sir.
Okay. Let's start the different cost involved into the projects. Based on that, we'll have the complete idea. So then we have the private benefits. So the private benefits, which means that actually, okay, you are making a direct gains and individual receives from the using of your transport mode. So what is the benefits you are giving gain directly from the using of your transport project? Either you are might be enjoying the speeds of the project by increasing from the 2-lane to the 4-lane roads. Then corresponding to that, so there is a kind of social benefits also can be expected. So these social benefits are the maybe like there is no kind of delay for each and every person. So then if there is no delay, so there is a no reduction of the speeds, then the loss of fuel corresponding to the emitting or increasing of the air pollution will also get reduces. So then obviously the private benefits result into social benefits sometimes up to some extent of period of the time. But beyond that, additional vehicles corresponding to the increasing of the delay that makes more consumption of the fuels, that makes more emitting of the pollution, that maybe increases your social cost instead of benefit. So then there is increasing of the social cost will be there. The private benefits always enjoyed by the individuals, but the external benefits enjoyed by the spillover effects of the society. So then if I want to know that the total societal benefits equal to your private benefits for external benefits, what makes the societal benefits? So you're not only enjoying the individual user of this particular road, it is also beneficial to the all the external people of the people along the road section or along the residential neighborhood of the sections of the corresponding the project. That we generally call it the total social benefit. So then the positive externality can be treated if the social benefits are greater than your private benefits. So which means that always it is very important to understand that. So suppose if you want to estimate a total positive externality of the project, we should not treat only the individual benefits of the users. We have to treat that what is the total social benefits we are occurring from the project. If you are achieving that more and more social benefits apart from the private benefits of the user, so then your external benefits are added into that respective to the each and every positive spill over there with respect to the society. Then you have the more societal benefits. But at what point of the time the social benefits are equal to the private benefits? Can somebody can point out on that, or can throw some light on that? Is there any chance that okay there is a equal value, the social benefits are equal to your private benefits? Hello?
Yes, sir.
Any points or any thought process when it will be the social benefit are equal to the your private benefits? It is very simple actually. In the formula itself we have, so like if you see that the social benefits are equal to private benefits, which means that the external benefits are zero. So that means there is no spillover from the project as the positive impact to the society. So why? What happens or why it can be happens like that? There are some points that in case the structure fails. Okay, I guess this question is related to the previous slide. Sir, in the case if the structure fails, how is the return to be considered? So if the structure get fails at the initial time period itself, then obviously we are not expecting any kind of the return from the your project actually. That may be treated as the big failure of the project. Okay, so no one is addressing that when the social benefits are equal to the private benefits. So the total external benefits are getting zero, which means that the individual what actually they are getting as the benefit, as the maybe saving of their travel time, considerations project in terms of the equity, that is balancing of the individual rights and the collective well-beings. So that's the reason. So the equity of the projects are very very important. So the best example if I'm taking, so like let us assume we have the very long corridor, maybe like best example of the Delhi Gurgaon expressway, like who are actually using this road have emitting the huge amount of the emissions, they might be causing the different types of the delays and it is always congested. Then who are actually residing of the people around the this category this particular road section, so it is expected that so there is no equity will be there with respect to the persons who wants to access the road. It is very difficult to them, but what are the negative impacts are there, all these negative impacts are imposing on the residents of this residing or the very close to the project actually. So that means that so what are the benefits you are achieving because of the expressway of this particular category of the section, so that may be enjoying by the individual users, but who are actually residing they don't have any kind of the benefits as the well-being of the public to the close to the public. So there is no balancing of individual rights to the users collectively corresponding to their well-being. Instead of that, the private benefits of the users are more. So there is always the trade-off corresponding to the what actually the closer to the project of the users of well-being is not actually balancing respective to the benefits are achieving from the project respective to the individual private users. So that is the right balance between the market efficiency with respect to the social welfare is not actually balanced. I hope you got the point how it is dangerous actually. So that means we are not looking at what is the social welfare of a project actually. We are only thinking that what the individual users will get benefit from out of from the project. So that's the reason. So if you look at the private benefits for the external benefits equal to the social benefits, so that is the benefits to the individual consumers or the firms, their economic activity, that is their private benefits, and the external benefits from that is the benefits to the others individuals, consumers, or the firm's economic activity of that particular project that equal to the total benefits of the society given economic activity. So this is the benefits to the first parties of the individuals, and these are the benefits to the third parties of the others respective to the other than the users of the project, and we generally are estimating as the total benefits. So now to understand that, so we need to go little deeper of the transport cost. So what is actually transport economist will try to look at as the transport cost. It is all about the different decisions based on the study of the transport cost. So these decisions may be like the fixing the price or the charging on the transport service. Like if you are operating a public transport bus, what would be the cost of your single trip of a user? So that may be your direct cost, but this cost will be actually estimated by different aspect actually. So that might be what is the operational cost of the bus, what is the ticketing respective to the your the persons who are actually involved in terms of the drivers or conductor, then the maintenance cost of the bus and the operating cost of the bus and the fuel cost, like the operating cost considered as the fuel cost, maybe like the diesel or like the grease or like the maintenance part of the bus together, what is the cost to be incurred of a trip per kilometer, something like that. So the designing the recovery mechanism. So we have the different types of the recovery mechanism. Generally, we have the analyzing the costing and the pricing pattern of the different transport modes are different respective to the different maintenance cost of the each mode. Analyzing the suitability and the feasibility of any project on the basis of the present and the projected cost of the transport is very important. So it is the cumulative value of the cost, inputting of different components like fixed cost, movable cost, manpower, mechanical, each and everything together. It is all about the cumulative price of all the inputs paid by the providing of the service by the users generally. So the cost output relationship can be given as the total cost can be given as the function of total production cost and the total output and the total service of the corresponding to the single trip or single activity driven by the person. Then we have the short term cost, we have the long term cost. So the short term cost is corresponding to the what is the total cost incurred of a person corresponding to the each and every activity the person who are actually doing. So then if you combine together of all the short term cost together, so then you may getting the long run cost. So then try to understand the short term cost. The short-term cost is the output relations reference corresponding to the assumption that made in terms of the size and the capacity of the production or service, and optimizing corresponding to the what is the profit you are achieving or maybe like the benefit you are achieving respect to the activity what you have done. Then what is the cost respective to that activity? Like if you are making a trip from your origin to the destination, that is your direct cost. Then what you actually making with respect to that production are the using of the service. So one requires to study the relationship between the output with respect to the following values or the following different cost. That is the total cost. Then we have the average cost. Then we have the marginal cost. So now understand that the total cost of a transport is the relevant to the service provided. Then certain investment need to be made. That is maybe like the total cost corresponding to the consumer service. Okay, that is maybe like what is the you have service provided to make the traveling from X point to the Y point. Then I use the service, then I kept as my ticketing cost. That might be your total cost incurred into the project. So it is called as the total cost. So then we have the fixed cost is the cost which is does not vary with the change of the output assuming. So that may be like the total cost may be corresponding to the fixed cost. So sometimes if you're going X to Y, so then you know the total distance to be traveled, then you know the what is the total consuming of the fuel. So then corresponding to fuel cost, then this is a fixed cost will be there with respect to the without variability of the cost. But if you are adding more and more vehicles into the network, that maybe increases that okay, there is increasing of the cost because of the reduction of the speed most probably, or maybe like the reducing of the speeds maybe causes more and more delays, then there is a more brake applications, then increasing of the brake applications makes that more amount of the fuel consumption, so that may be increasing of the cost. So then we have the different types of the variable cost involved into that apart from your fixed cost. That may be respected to the variable cost, maybe corresponding to the sometimes you like the components which are involved into the operation of the vehicles. Sorry. So now if you see that, so these are the kind of components involved into the fixed cost and the variable cost. So the fixed cost involvement of the capital cost, the registration fees, insurance, and the road permit charges and the other taxes. Then the variable cost, that is the distance related to the components. Then the fuel consumption, spare parts, tires, lubricants, and the time related components. We have the depreciation, then the value of the passenger's time, then the wages of the crew. So these are the parts generally involved incurred into the project, so that to be treated or considered as the variable cost. So any questions at this point or any points to be discussed? So you understood like what are the different types of costs are there?
Yes, sir. Right now we can understand.
Okay. So let's start the other components of the cost. So now with that, so let's make some kind of idea. Like if you have the kind of bus operators, service operator we have. So then what are the different costs involved incurred into the bus operations in general? Like if you are implementing a kind of project to increase the frequency of the bus operation, is it really worthwhile to increase the frequency of the bus? Then we need to understand that what are the different components of the cost incurred into the project. So for that, so the factors are related to the total fixed cost to be estimated first. That is the cost of the bus and the cost incurred into the procuring of the license, permit, insurance, salary of the drivers and the conductor, and the office expenses, maybe like the interest and the depreciations and the taxes levied on the state, depot charges like this. So then we have the different variable cost, that is fuel, parking fees, because the fuel cost cannot be as fixed as, because sometimes we understood that so there is a variability of the cost corresponding to the fuel by adding up more vehicles on the network. That might be increasing that delay, that consuming of more fuels because of the brake applications. Then we have the parking fees, we have the terminal fees. So then apart from that, we have the different chalanas, tolls, something like that. So now if you see that, so the total cost of the operation equal to the total fixed cost plus total variable cost, then we know that what is the total operation of a single bus. Then we need to look at that what is the demand for that bus. Then I know the supply, I know the demand. So then you need to make a supply demand curve. So which makes that, okay, you have the supply demand curve respect to the equilibrium price, like you have the demand. So that is the corresponding to the price, how many number of buses to be operated. That is the quantity of the bus operated, uh, or sorry, quantity of the people demanded to the respect to the price. Then you have the supply. So how many number of buses to be operated. So corresponding to the equilibrium value of the price and the demand, or supply and the demand. So now if you keep that, okay, there is a kind of chances that, so according to the equilibrium price, so even if you are operating the bus respected to these many number of people, that is a quantity demanded respected to the equilibrium price value. So this equilibrium price makes that this is the price as ticketing price probably corresponding to the ticketing price. So these many number of people can be demanded. So I know the price, then I know the demand, then corresponding to the price, if I'm operating more number of services, then how this service or the supply will be going to changes. Then change of the supply, then how it is the demand changes, what is the price changes, then we need to estimate it. So then we can understand that whether this feasible or not feasible to operate more number of buses or services. So then corresponding to that, we can also expect what is the average cost involved incurred into that, that is the average total cost. So generally can be estimated the total cost divided by quantity estimated. Then we also know the fixed cost, that is the total fixed cost divided by quantity, that is the average fixed cost. The same way we have also the average variable cost, that is the total variable cost divided by total amount of the quantity divided. So what is the variable cost is indicating, so like what is the marginal value changes get changing of the, instead of operating the 10 buses, if I am operating the 8 buses, then what is the change in terms of the quantity demanded and what is the change in terms of the cost. So that's the reason the marginal cost is very important parameter to understand, to make any kind of externalities respective to the project by looking at the different cost perspective of the project. Like I have the total cost, I have the total fixed cost, I have the variability cost. Then I need to understand that, okay, if I want to make them to operate these many number of buses, then what is the my variability cost is there respective to the change of demand to the price. Okay, let's understand more into the marginal cost value. So in transportation, it refers the additional cost incurred when providing a one more unit of the service. That may be like the one additional passenger trip or one additional extra vehicle on the road, as maybe like the even one additional ton of the operation of the vehicles which is moving on the specific route category. To understand that what is the capacity of that particular route and what is the optimal value in terms of the cost or price, like what is the optimal price if I want to make a trip from X to Y, and how many number of trips generally the people are making, and what are the kind of modes generally they're using. If I want to change the trip corresponding to the public bus to the vehicle, okay, I am going to change, instead of using of a public bus, I am going to change into the vehicle. Then what is the marginal cost value between of my trip X to Y? Instead of traveling by bus, I am traveling by car. Then what is the value, additional value I am going to get by changing of the mode? So I may be getting as the travel time reduction, probably I'm going to get as the access time may be reduced completely because I'm traveling by car directly from my home to my office instead of traveling by bus. So then that makes that okay, there is a opportunity cost is also involved. The opportunity cost, you are not traveled by bus but you have traveled by car, then you have saved this much amount of the time, and but you have kept for that opportunity as additional cost. That may be like the fuel consumed between X and Y when you travel by your own vehicle, that is your car. So then there is an additional cost incurred into the trip instead of traveling by bus. So now by mathematically, if you want to look at the marginal cost is nothing but change of the total cost divided by the change of the total output. So if I want to know that what is the total change of the cost in terms of the operating of the more buses, then what is the total change of the demand respective to the more buses? So then this marginal cost can be given at the different period of the time. If you are adding a n plus 1 number of vehicles and respect to the n number of vehicles, what is the total amount of the cost? So then additional value of the bus respective to that, what is the change in the demand? That is the marginal cost can be divided as or can be given as change in variability cost, that is the total variable cost divided with total change in the demands. Now if you can easily understand now how this can be understood by pictorial forms. Then you have the cost, then you have the output, then you have the marginal cost value, then you have the average total cost value, you have the average uh, variable cost value, then you have the average fixed cost. Mostly if you see that the average fixed cost is the kind of linear line almost, but the variability cost will be get varies respect to the total cost, because the average total cost equal to the average variability cost plus average fixed cost. If you have the more and more variability by adding of the vehicles into the network, so then there is increasing of the delays, then there is a variability is increases. So then there is a more variability cost, then your marginal cost will also get changes respect to the change of your average total cost to your fixed cost. So basically we need to look at that what is the kind of quantity demanded respect to your change of the marginal cost corresponding to the different values of fixed cost, what is the quantity demanded corresponding to the average cost, what is the quantity demanded, what is the corresponding to the average total cost, what is the quantity demanded. So this quantity demanded respect to the prices, we always look at that whether it is really optimal to implement the system or service or not. Okay. Any questions? Yeah, almost I done. So the some part of the understanding that the cost and the demands and the supply side. So if you have any questions, we'll discuss. Otherwise, we'll stop here. So maybe Professor Vinayak will continue the discussion with respect to the demand and supply. But I will share this PPT and we will also continue to discuss maybe some session tomorrow or like the next few sessions, next classes. Otherwise, any questions you have? Is it interesting or boring completely?
It is interesting, sir, but it is first time to get
Okay.
such all such information. So that's
Yeah, when we are looking as the maybe like the demand supply side more and the equilibrium prices and that, then you will get more clarity on that why this cost will be important and how this cost need to be looked at. Even if you are estimating a crash frequency or the crash barriers cost actually, so this analysis is very important. Okay, let us assume that okay, you want to reduce a number of crashes on the road system. Then if you are incurring a project as a cost of the some amount equivalent to that, so then how this cost will be looked into condition to consider that barrier, or if I'm not implementing, then how many number of accidents going to be up. So that means I need to make a cost of accident, then I have the solution as the barrier. So then if I'm looking that, okay, what is the variation in terms of the number of crashes respective to the incurring of your project respective to the given barrier system. Like there are different ways we can easily understand of this cost analysis generally, that or we generally call it the transport cost analysis. Topics are interesting and very future interesting, and some of these things are totally new given things. Okay, yeah, basically most of the PG or even the different colleges, so these transport economics are given very less important, but this course is very important at the PG level. So if you are not have any chance to read, so then we are going to send all the materials, just refresh it, then you will get the so much of clarity to make different kind of the directions of even for your research. And there is a more interesting sessions will be there on the fourth day, that is the CG models actually, if you recall, as per the schedule. So then like in the CG models, that is the one of the new topic even for me also. So this is the one of the more interesting area to explore it for the further research actually. So continuously taking or like talking is also not good. So that's the reason I'm stopping here. So we'll continue the next session with the Professor Vinayak. We're going to join with maybe in another 10-15 minutes. The next session will start at the 11:45. So is it okay, or shall I continue a few more slides? I guess better to stop.
Yes, sir.
Okay, then we'll meet again at the 11:45. Thank you all.
Thank you, sir.
All right.
Slides are visible, sir.
Slides are visible. Okay. So, okay, perfect. So, what we're going to do, first of all, any questions from yesterday, or any doubts you all would like me to address? All right. And again, if you all don't mind, just because I won't be able to view the chat screen, if there is anything on the chat, if anybody can just let me know, so then I can try to address them as we go, or just feel free to interrupt and speak at any point.
Okay,
So,
sir.
yeah, perfect. Thanks. So, what we're going to talk about in today's lecture is more around demand. How do we model demand? And I know that there have been a few slides we have already talked about looking at logit models and all of that. But we'll go a little bit more into the details and the depths of it. And we will also go through a few numericals around that and examples of it in today's lecture, like in the lecture now and also later this afternoon. All right. So what does demand mean, right? Like, what does demand mean? So demand basically deals with choices. So individual choices, or in the case of transport, some of these choices are household decisions as well. So, for instance, the decision of whether or not you're going to buy buy a vehicle, that is a household choice usually, and these choices are affected by a lot of factors associated to person and household characteristics like age, demographics, etc., which actually Raghu was discussing and pointing out to in yesterday evening's lecture, right? The other one is trip characteristics. Trip characteristics include the cost of the trip, the distance, the travel time, the service characteristics. So the service characteristics, how comfortable it is. So for instance, a lot of people, even though there might be, it might be faster to go via there's certain sections where it might be faster to go via a boat. People prefer not to go because they might get seasick, etc. So the service characteristics also affect an individual, the choice. For instance, I'll just give you an example. Like one of the things which we are currently studying in collaboration with a big electric vehicle company is uh, there is a particular reason why a lot of people are a bit worried about using electric vehicles. So range anxiety was one, but now people are quite comfortable with the with the trust in the electric vehicle. The main reason has also been because it induces motion sickness. So there is a lot of studies which are showing that electric vehicles actually induces motion sickness. So people are trying to avoid using electric vehicles to ICE vehicles. So those are some of the service characteristics. Land use characteristics. So one of the aspects of land use characteristics is how safe a person feels, right? So there are areas where people are not feeling safe when they're walking or doing or walking as a mode or cycling as a mode is not conducive to the safety during that travel. So land use characteristics affect the choice. Any questions so far? So one of the questions that always you hear is how can we encourage transit use, right? People are always, because one of the big things that happens is we all are we all experience a lot of traffic congestion when we are driving or moving around in our around the network. So there's always a policy question about trying to increase transit use. So how can you improve it? So the two main ways of doing that are one is of course reducing the cost of transit, improve the level of service. Uh, uh, there's something called high occupancy vehicle lanes, which is basically nothing but bus rapid transit, right? Like so having dedicated lanes so that it is not affected by the road congestion. Then increase parking costs, so that what you're doing is not making the cost of transit cheaper, but increasing the cost of using a vehicle, restricted car use, tolls, gasoline tax, etc. So we will try to include some of these in our in the examples which we do, but this is always one of the policy decisions. And these kind of policy decisions can be in different forms, right? Like, so one form is how can we increase electric vehicle usage, right? How can we increase the uptake of electric vehicles? That has been, so the one way which governments usually, the one lever which the governments usually know of and have used it widely has been using subsidies. So there's a wide range of such policies that are put forth to make that case. Now, why is it important from a perspective of economic assessment? Because at the end of the day, economics is about supply and demand, right? So the supply is associated with uh, the road, the congestion, the price of traveling, and the demand is affected by that. And the economic benefits, or the economic benefits adhered, or economic benefits realized to the people, are associated to how much, how many demand, how many people are experiencing those benefits, right? So you might increase the cost, but the very small people might be actually, like for instance tolls, you might increase the tolls, less people are traveling, but the number of people, but the congestion has reduced, but the amount of people who have experienced those benefits are smaller. So what is that supply demand curve looking like? And that's why the demand aspect is important. Any questions so far? All right. How many of you have actually done any kind of discrete choice models or demand models? Yeah, Manish.
Sir, I attended one of the course, but practically I didn't did, did anything.
Okay. What about you, Rahul?
Sir, I am the Rahul sir who
Yeah.
was speaking. Yeah. Sir, I attended one of the course,
Oh, okay, Rahul, you were mentioning. Okay.
but practically I didn't do any uh, example.
So now that so one thing which I would really encourage you all to think about as we go through this is try to think about how we can be using it, right? Like I'll try my best to uh, to to pull from my experiences and my understanding and how I have used it. But question about how is this useful or how is this not useful, and why, how, where can you be using it? So always ask that question, because I don't want you to feel like this is, I give you all this information, but it is not contextualized to the use, right? So that is an important question about how can I use this. Now, where is this actually, these demand models used? These demand models are used when we are trying to understand mode choice, right? Vehicle choice. All of these are where we are actually using these logit based models. Like for example, I'll give you one place where it is really, really useful is around high speed rail. The question that is being asked is whether um, what is air travel? How will people actually shift from air travel to high speed rail? Is there enough capacity for that? The second question that that keeps coming up is for freight. Will people move from road to rail? Of and those are the type of questions where these models are really useful. And then the question comes, how do you build these models? What's the kind of data we need? And we'll try to talk through that. So think about those questions as we go through this set of lectures. All right.
Okay, sir.
Perfect. So we are going to start from the very fundamental pieces, right? So I'll try to, it gets a little mathematical from here, but at the end of the day, don't get, I mean, we're all engineers, but if at any point the maths is not making sense, tell, and I'll try to explain it out in a very intuitive way, because uh, there's always, equations always make sense and the world makes sense, but it's really important to connect those two, and that's always the challenge sometimes. So the fundamental problem, and you know, Daniel McFadden, right? Dan McFadden actually got the Nobel Prize for this. So, in fact, the area of transport and transport economics, and in fact, even physics of traffic, there have been people who have got Nobel Prizes. So Dan McFadden actually got the Nobel Prize for looking at mode choice and choice on route choice. So his idea of the logit model was what got him the Nobel Prize for economics. And it was based on transport. The use case was transport. The other person was Prigozhin, who did a lot of work on looking at the physics of traffic. So these are fundamental sciences which actually are very interesting, and people pull from physics, pull from economics, and something interesting always comes together. So the just getting back now, that's a side story, but getting back to the fundamentals of this, right? So the question we are asking is, given a whole bunch of uh, uh, options, what will an individual choose? Right? So I can choose a rail, I can choose ship, I can use a car, I can use a taxi, I can use a cycle, I can use a bus. How do we choose? And what would be a systematic model to actually make that? So there are two aspects to it. One is the attributes of the mode. So there's a bus, you're going to be sitting with a lot of people. It is fast, but it is not as fast as a car or a taxi. It's cheap, right? But takes longer than a car and a taxi. Cycle is very cheap, but very slow and very exhausting. Train might be expensive, like particularly train might be expensive than a metro might be more expensive than a bus, and so on. So there are these attributes and characteristics of the mode which are very, very specific. Then there are individual characteristics. What is their income? What is their age? Where do they live? How far they want to travel? Household. So a lot of people ask. So one of the I used to travel a lot using public transport, but of late I'm having to use my car, and a lot of that has to do with the fact that I need to drop my children to school, go to work, then actually need to pick them up and bring them, and I can't do that very conveniently in Sydney, at least right now. And that is what is affecting my choice, is because of the requirements of me needing to do these trips. So the individual characteristics also have an aspect of trip characteristics as well. So the whole idea of doing these models, the demand model, is based on the idea of probabilities, right? So if there are two modes, you have a probability of choosing mode 1 or a probability of choosing mode 2. And this is called a logit model. And one of the most interesting things about the logit model is when the Nobel Prize for Dan McFadden was actually announced, it was the only other Nobel Prize in which the equation was put in the newspapers. Do you know of any other one which could have been put? Because it's so simple, right? Like the probability is equal to exponent of V1t divided by the sum of exponents of the V1s. And I'll talk about what the V1s are. Can you think of which would be the other equation that might have come onto the headlines when a person got a Nobel Prize?
No, sir.
It was actually E is equal to mc square for Einstein, but he didn't get the Nobel Prize for E is equal to mc square. He got it for photoelectric effect. But the funny thing is that this is the only other one for which it has got. So you're learning history, which is a very, very fundamental property of human nature, which has been captured in this very simple formula. And it's amazing, right? Like if you think about it, that this formula can actually predict how people behave and how they make choices. So now I'll talk you through what each of these terms mean. All right. So V1T are called utilities. So it's basically telling you what is the utility of uh, mode 1, and what V2T is the utility of mode 2. All right, and usually it is written as a linear form, but you can have a non-linear form as well. So V1t is equal to alpha 1 plus beta C1t. Now C1t is the characteristics of the mode 1, all right, plus gamma 1 AT, which is the attributes of the person, which is the traveler, right? So the probability that traveler T chooses mode 1 is this, and probability of traveler T choosing mode 2 is this. So in this thing, right, in these utilities, you have this modal bias, which is alpha 1 and alpha 2. So what it's saying that there is some aspect of habit or some bias that a person has a higher utility or a lower utility for a certain mode. All right, so that's what it's basically capturing, this constant, alpha 1 and alpha 2. C is basically the cost or the service aspects of it, which get captured in C. So mode 1 will have a certain cost structure and service structure, and mode 2 would have a different cost structure and a service characteristic. So that's C to T. And AT is the socio-economic characteristics of traveler T. So these two terms are what is basically what you're able to observe in the data. All right. So what we generally do is we do a survey, right? So they're called stated choice preference, or we can also do revealed preference, where we calculate, we get information about different bus routes and different vehicle routes, and we're getting different C1s and Ts. And we do a survey with a lot of people. So we get different ATs, which is basically different attributes for different types of people. And then what we do is we have to actually calibrate alpha 1, beta, gamma 1, alpha 2, beta, and gamma 2. We are calibrating for those, right? So we'll come to how we do that. And we plug this into the equation and we are able to get two probabilities. So what you can literally see is if I add these two probabilities, it will become exponent of V1t plus exponent of V2t divided by exponent of V1t plus exponent of V2t. So the numerator and denominator cancel off, and you end up with P1t plus P2t is 1, right? Any questions so far? Sorry. Any questions? All right.
No, sir.
So this is basically giving an example of what a binary logit model. So what we talked about was basically a binary logit model. So binary means 2, right? So you have only 2 modes. A multinomial logit model is when you have multiple modes. So the choice probability pk becomes exponent of vk divided by the sum of exponents of all the k choices, k options. Is that making sense? Yep. So basically, if I go back, one of the things I can do here is if I divide the numerator and denominator by v1t, exponent of v1t, it just becomes 1 divided by 1 plus exponent of v2t minus v1t. So that is p1t. So that's exactly what this is saying, is that pk is 1 divided by 1 plus sum of the exponent of the differences in the utilities, right?
Yes, sir. Yes.
All right, so now let's just take an example of a 2-mode case where, and the whole purpose of this is to try to figure out how we go about choosing this. So it's just an example. So the utility of the bus is equal to the value of bus plus some error term. So the question is whether I'm going to choose a bus or an automobile. So it's a car. Now the value of the bus, so that's the utility function, is minus 2 times travel time on bus. And the value of auto, so the utility of taking a car, is 1 minus 2 travel time of auto. So what is this telling you? That there's a 1 is telling you that there's an inherent bias towards going on a car. All right? Right? So when the probability of choosing the automobile mode is 1 divided by 1 plus E V bus minus V auto. So that becomes 1 divided by 1 plus E minus 1 minus 2 T cap minus T, where T cap is the time taken for auto, for the car, minus, no, sorry, for the bus. Yeah. Yep. Bus and that is auto. Yep. Yep. That's 2T bus plus 2T auto. Yep. So if the travel times were the same, what would this mean? This would just be 1 divided by 1 plus E raised to power minus 1. Okay.
Sir, I am not wrong. Auto requires less travel time compared to bus.
Usually it does, but what I'm saying is that let's say that the travel time on the car and the bus is equal. Just because there is congestion, the travel time on the bus and the car are the same. So what would happen here? This would be 0, this term.
Yeah. Yes.
So this becomes 1 by 1 plus E raised to power minus 1, which is which will be, I'll just tell you, just to work. 1, sorry, 1 divided by 1 plus E plus 1 divided by E. That's around 73, 0.73, 73%. So even if there is the travel times are equal, people are going to choose car. There's a higher likelihood of choosing car, which is basically because of this bias here on 1. And 27% would take bus if the travel times were equal. All right.
Yes.
Now, if there are 3 modes, then this becomes E raised to power V car divided by E raised to power V train plus E raised to power V car plus E raised to power V ferry. And that's basically what the choice probabilities are. All right. So one thing I want to actually highlight here. So a couple of things when you're actually, so there's a specification aspect of these models as well. One thing to remember is that you have these mode specific biases, all right, alpha 1, alpha 2. But when we are looking at the costs, when we are looking at the preferences, the coefficients associated to the costs and the mode specifics as well, they are constant. So what we are trying to say is that people prefer the differences on the cost or the differences in the services in the same way, right? So if I take the partial derivative of any of these utilities with respect to cost, they are the same, right? The elasticity is going to be the same. But different people might have different preferences. So different attributes of the people might have different preferences towards each of these modes. That's all. All right. So that is just an important thing to remember, is that these betas are always same. these gammas might be different, and these modal biases are different. So like, let's look at here. A very simple example, the modal biases are different. So this modal bias here is 0, this is 1, but the preferences over the travel times are the same, it's -2. But this might not be the case as well, but this is what it is. Like, you can have different assumptions. Usually we try to keep it the same. Any questions so far?
So that beta value is always constant, or it is vary for case to case?
It varies. It varies place to place for different populations. So usually the way you try to estimate that is through surveys.
Means which type of service? Sir,
So
may I
they're
know?
called stated preference surveys.
Okay.
And probably what I'll do is I'll try to create an example for you this afternoon when we do it. So what it'll show you is, it'll show you a bus and it'll show you a car, and it'll show you that this one takes travel time this takes a cost this. So which one would you choose? So you make a series of choices, and each one of you will make a series of choices, and then we can estimate the value of time and the preferences around it. We'll do an example. We'll do an example this evening on that, on how
Okay.
we estimate it.
Okay. So in case that household survey, that type of survey we are conducted, so go
Yes,
to public and ask which type
you
of
have to.
module.
Yeah, exactly,
Yes.
exactly, exactly. Then, okay, so this is another example of something called the red bus, blue bus example. I don't know, have you ever heard of this example? Have any of you heard of this?
No, sir.
No, okay. So this is just a thought experiment, and it leads to a paradox. Okay, so what we are saying right now is, let's take this example that uh, there's a car and there is a bus. Okay, and the utility function of both of them are exactly the same. It's alpha times travel time. All right, and we assume that the travel time is equal. It is 10 minutes, and alpha, which is basically giving you some kind of value of travel time, or the preference function, that is minus 0.01. So one of the questions I'm going to ask you is, why should it be negative? Why do we always have this alpha as negative? Like, even if I go back, you'll notice I had this value here negative. What does that mean? Any ideas? Any thoughts?
According to me, it is considered as a delay.
Correct. So what does that mean? So if travel time is a delay, what does that mean? It is a disutility, right? So what it is saying, if I give you more travel time, my utility is reduced, right? So that's why it should be negative.
Yes.
So more the travel time, the less I don't like it. So it's a disutility. So that's why a lot of the coefficients for travel time is negative. The coefficient for cost, right? How much money? If I give you more, if I have to pay more money, that is going to be negative. But if there is AC in the bus or in the car, that is a utility. That's a positive, whether or not AC is there. So the coefficients of these parameters actually tells you a lot of, gives you an information about whether people like it or don't like it. Okay.
Yes, sir.
So in this case, alpha is negative and it's negative 0.01. All right. So what is the probability of taking a, let's say, a car? The probability of taking a car. So it's literally exponent of minus 0.01 multiplied by 10 divided by the sum of these two. because the bus and the car have the same utility function, same travel times. So the probability of car is half, and the probability of taking the red bus is half. Okay. So then one of the person comes in, one of the, let's say, one of the senior executive comes in and says, look, I really think that people care about colors, and they, the more colorful the buses, the more it will increase the increase the uh, increase the share of the people taking public transport. So what they do is they take the red buses and take half of the red buses and paint it blue. So you have now car, red bus, and blue bus, right? So we now repaint it and make it this thing. So what does that mean? So it's P1 exponent of V1 divided by exponent of V1 plus V2 plus V3. So what's the probability of a car now? It is 0.333, right? It's 1 divided by 3. So the probability of car is 0.33, probability of the red bus is 0.33, and the probability of blue bus is 0.33. So now what is the total probability of taking a bus? It is 0.67, right?
Yeah. Yes.
So what has happened? By just putting it as blue, it has become, we have increased the modal share. Does that make sense?
No, sir, but we have just changed the color, but the capacity of that bus or car will be same.
Yeah. So what do you think? What is happening? What do you think is happening? It actually brings to surface a fundamental mistake we have made when we are doing this analysis. A bus is a bus. It doesn't matter if it's a red bus or blue bus. A bus is a bus.
Yeah, correct.
So what we should be doing is something called a nested logit model, where you say that the probability of a car is probability of a car divided by the probability of a exponent of a car divided by exponent of car plus exponent of bus. So that will give you the bus. But now there's going to be a second order issue where the bus is got two choices. You can either take a red bus or a blue bus. So you'll end up having the probability of a car is half, the probability of taking a red bus is 0.25, and the probability of a blue bus is 0.25. So you're taking half of the probability of bus. That is what is called a nested logit model. So the way you would be actually looking at the probability of the red bus is basically, if you look at the top, I've just kind of given you a, or let's start from here, on the left side on the top. The probability of a red bus is actually the probability of taking a bus multiplied by exponent of the utility of red divided by the sum of the exponent of the utility of red and utility of blue. So that is basically P red bus is equal to e raised to power v bus divided by e raised to power v bus plus e raised to power v car. That is 0.5, and this is 0.5 because again the utility of red bus and utility of blue bus are the same. Am I making sense? So the biggest mistake people make is they think of them as independent. The red bus and blue bus are not independent. They are dependent choices. They are actually nested choices. But car and bus are independent choices. Because you would, once you have chosen a bus, is when you're going to decide that you're going to take a red bus or a blue bus. Correct?
Yeah.
So that is the issue of IIA. Why am I? Nobody has asked me why am I mathematically and paradoxically, this is all fun. But why is this important? This is important because when people are doing these demand analysis and doing economic assessment, they tend to make these mistakes. And it's important to ask the question, are the options in your choice set independent or not? Yeah?
Yes.
All right. Any questions? Sorry. All right.
Sorry, sir, I interrupt.
Yeah.
You say that we are considering only two types of choice, means car and bus. It does not
Correct.
matter it is red bus or blue bus. But in case we are considering the demand, we are also considering the capacity of the particular bus. Because when we have probability of blue bus or red bus, there will be variation in capacity of that two bus. Means the red bus having more number of sitting capacity compared to blue bus. So this consideration we have taken into in this part, or you have taken any another step to take on that capacity part.
So if you look at the capacity part, the first thing is in our assumption, right? We have not changed. We have just taken the number of buses were the same. I've taken those buses and I've painted half of them blue,
Okay.
right? So I've not done any changes to the capacity or anything like that.
Okay. Now, in case there will be some.
Yeah. So in case I have two types of buses, like let's say, like I have two types of buses within the bus. Like let's say one is a luxury bus and the other one is a normal bus. Still, what you would do is something like this. I would have a probability. First, the choice is between a car and a bus. And then once you choose a bus, you're going to have e raised to power v luxury divided by e raised to power v luxury plus e raised to power v normal. Right?
Yeah.
So,
Yes.
because there is a fundamental first piece of a choice which people make about whether they're going to choose a bus or a car. And once they choose the bus is when they're going to choose whether they're going to take a luxury or not.
Okay.
And that is how we call it as nested choice. So, all right. So let's give, it's basically capturing the decision levels and the fact that these decision levels impact the idea of IIA, the independence of alternatives.
Okay.
So IIA stands for identically independent alternatives in terms of errors, right? So the errors, so the whole the way this I won't go into the derivation of this, right? Like maybe here, the way these are derived, right? The way a lot of the logit model is derived is that we have these error terms. So if you look at the utility of the bus or utility of auto, there is a random error, right? So generally we assume that this random error has a something called a Gumbel distribution or a normal. If it is normal, we call it a probit model. If it is Gumbel, it is called a logit model. So with this error term has to be identical. The distribution of these error terms have to be identical. Now, the error terms of the bus and the auto are identical, but the error terms of a luxury bus and a non-luxury bus are not identical to that of a car. They are identical amongst themselves, the error, but together their errors are actually equal to have a similar distribution as that of a car. So it has to do with identical identically independent or independently identical alternatives. That's what distributed alternatives, the error terms. So generally the way it works is, again, at any level, the error terms have to be independent and identical. So then after a passenger car, you can either drive alone or shared ride. So these two are independent and identical. But these two together here are correlated. They are not independent. These two with transit are not independent because these two are correlated in some sense, but are independent under the passenger car. So the passenger car is picking up on the correlation matrix in that. There's an entire maths behind it. I won't bore you. There's a separate class we can go through it. It is really interesting and it is quite extensive. But in short, without getting into the maths, the way to think about it is each decision level has an independently distributed error term, and they come together and create a new decision. So the first level is whether I'm going to choose a car or a transit. But once I choose a car, should I be driving alone or should I do a ride share? If I choose a transit, should I take a bus or should I take rail? If I choose bus, should I take a red bus or should I take a blue bus? Or should I take a luxury bus? So that's how it works. It's called a nested logic model. So this gives you an example, right? Like, so this is how it works. So first is a passenger car. So this is your first level. That's the probability. The sum of these two probabilities is going to be 1. Right? Can you see that? The probability of passenger car plus probability of transit is equal to 1. Then given a passenger car, am I going to choose driving alone or am I going to choose a ride share? So that will be, the probability of that will be this multiplied by this. The probability of this will be this multiplied by this, and so on and so forth. And sum of these, all these probabilities with the products will be equal to 1 again. Yeah?
Yes.
So let us do an example now. Another example. So this afternoon, what we'll, like I said, we'll design a survey and see how we can actually go through developing a market share, like basically setting up a, how do we decide, how can we actually how do we calibrate these parameters? We will talk through that as well. Do you all have access to ChatGPT and all, like easily?
Unpaid version we have.
Huh? Most of you can access ChatGPT, right?
Yes, sir.
So we'll probably do this on ChatGPT only, like where we change. So I'll create an example and then we put it in the ChatGPT and it can give you instead of. So I don't want to spend time teaching coding and trying to do regression analysis and all. But what we'll do is we can put it into ChatGPT and the ChatGPT can do a regression. So I'll test that out and we'll go through that later this afternoon. So this is an example of market share. Okay. So if utility of a particular airline is just alpha times fare, all right. So we know that the fare of A is $1,000, then the market share is 30%. If the fare of B is $900, then the market share is 70%. Find alpha. All right. So we know that the choice probability is e raised to power UA divided by e raised to power UA plus UB. So we know that airline A is 30%, that's equal to this. Airline B is 70%, which is equal to this. This is basically how we end up figuring out what alpha is. All right. So we have basically one variable, one equation, and we solve for it. So basically you end up with this. It's fairly straightforward. So alpha is equal to 1 divided by 100 log of 0.3 by 0.7, 3 by 7. So which is basically minus 8.5, 10 raised to power minus 3. And again, you can see that the alpha is negative, which basically says that there is a disutility associated to fair. Yeah. Any questions? Any questions?
So all this analysis we are doing in Excel, or there will be any software that we will use?
So we can do it. I'll give it to you all in Excel, and then what we can do is we can put it into ChatGPT also. So you can see that the ChatGPT can do a regression analysis. I'll try to do that. I'll try to do some tests whether ChatGPT can do it well or not. But I think all of you can access ChatGPT, right?
Yes.
And I'll show you. Basically, the idea being that now you might not need to use regression analysis. Like you can try to use generative AI for some of these very simple analysis. You still need to code if you have some complex analysis to do. But we'll go through that. We'll go through that example this afternoon.
Okay.
So we did market share. Now the second question is, let's estimate the price that will attract a given market share. So this is always a question. So now based on current data, we have estimated alpha. Okay. We have estimated alpha. Now what we need to do is actually, given this alpha, figure out how can we get a 40% market share. So I want to increase my market share by 10%. So how do I get that? So what should be my price, X? So I know my alphas now, and I know that airline B is charging $900. So how should I get 40%? So that will be, what should be the price I should charge? So basically, this is the equation we are going to try to solve. Log of 0.4 divided by 0.6 multiplied by x minus 900 divided by alpha. So this is log of 0.4 by 0.6 divided by alpha plus 900, right? So it's going to be a little bit more than 900, right? It's going to be a little bit more than 900, which was basically $947.70. It has to be less than 1,000 and greater than 900. That we know. Am I making sense so far? It's a simple linear equation which you're trying to solve for.
Yeah. Yes.
So in a lot of these economic models, what you can do is you can say that this is my economic assessment, right? Like, for instance, I am based on my model. So first you derive your model, and then you say what should be the price I should be charging so that I'm only able to get 30% of the demand. So I'll give you an example. One of the things that happens is when you have a very cheap metro rail, right? There is so many people who end up coming that you want to make sure that you're providing a certain service level. So what you do is you increase the price a bit so that you reduce the market share, but what you're doing is you're getting a higher revenue. So if I look at my revenue, it is basically 0.4 multiplied by 947, right? Which is into
379.08.
379.08 as opposed to 300 when it was 0.3 multiplied by 1,000, right? So by dropping my price, right, and increasing my share, my expected revenue has increased by almost $47. Correct? Is that right? Or am I wrong? Let me just look at 947.7. Yeah, 379. So almost by $79, you have increased your expected revenue, right? Per person, you have increased your revenue by $79 because even though you have reduced your price. Am I making sense? Or no?
Yeah, yes. It is first time it is difficult to understand. But
Okay, so
okay.
I'll try to do this on an Excel sheet. Let me open up an Excel. Let me try to explain this concept it is it's a bit counterintuitive, but it'll make sense. So let's say I have a price and I have demand, right? Let's say my total demand is 1 lakh people. Okay, that's roughly 100,000, but 1 lakh people. So for 1,000, so this is the price of A, and this is the price of B. Price of B has always been 900. When price of A was 1,000, the demand was equal to 0.3 multiplied by the total population, and each person was paying how much? 1,000, correct? So that is roughly around 1, 2, 3 crores, roughly around 3 crores. The moment I drop this to 900 and
sorry, sir, I interrupt you. That demand you have calculated, how many time interval you have considered for this 1,000?
It could be it could be over a year.
Okay.
Doesn't
Okay.
So the time period is constant for both situations. It could be a year, it could be 2 months, but here I'm just assuming. Maybe let's reduce this to 1,000 people. So let's say it's in a day.
Okay.
So my annual revenue will be my daily revenue will be around 3 lakhs, correct?
Yeah.
Now my annual revenue, my daily revenue, if I reduce it to 947, it will be equal to that price multiplied by 0.4, because now I'll capture 40% of the population, multiplied by 1,000. That is 3,79,080. So my total revenue has my profits, right? My revenue has increased by
79
that is equal to this minus
minus this.
And if I want to look at the percentage, this is divided by 26%. So my revenue has increased by 26% by dropping my prices by $50.
Yeah, got it.
So this is the kind of economic assessment you can actually be doing, is by, if you drop my prices, I can actually increase my revenue. But also if the demand is too high and it is causing congestion, that means your prices are low. Try to increase the prices. You will still manage to you'll increase your revenue, but you'll still have a fairly comfortable demand. Yeah.
Actually, sir, I give a real example on that because actually I am based on Mumbai, so I really travels to local train. So in Mumbai, there will be proposes two type of local, AC local and normal local. So we see that the normal local trains fare will be same, means past 10 year will be same, no increasing, no decreasing, will be same. But in AC local, there will be the fare will be increases by 2 years or 3 years to increasing their demand, or they also provide some facilities. But
Correct.
but we see in the means the practical life, we see that the lot of rush will be come to the common railway, not go for the AC train. So it is also the disadvantage of that. Means
Correct.
we have maintaining the both the balance
Correct.
for that
Correct.
economics point of.
That's a great example. That's a great real life example.
Yes, sir.
Perfect. So, we've gone through that. This is another example which we are going to be doing, where you have a private car which has this utility function, and a public car which has this a public vehicle which has this utility function. So there is, the way this is set up is, there is a bias, of course. This constant is the modal bias. Then you have an in-vehicle time preference. So the in-vehicle time in a car is different than an in-vehicle time in a public, in a bus. If you look at it, in fact, there is more disutility associated to sitting inside a car alone versus actually sitting in a public transport, looking at people, being able to do other things, talking on the phone. You can't talk on a phone when you are inside a car, or text. You can still talk on the phone, but you can't text. So basically, because of that, sometimes your this variable, the in-vehicle time preferences, are a bit higher. The disutility is lower, and the out-of-vehicle time is higher at a bus, because you have to actually go walk a little bit longer. Here you have to walk less to your this thing, and the cost also is different. So these are your preferences. So the question is, what will be your probabilities? Find the public transport usage level. So what we do is we plug in the numbers, and we get that the private has a utility of minus 1.4 and public has a utility of minus 2.7. So the probability of choosing a public transport is 21.7%. Literally, we just put in the values here. Simple. Yeah.
Yeah. Yes, sir.
Okay. So these are some of the examples associated with the demand side of things. Now I want to do a little bit around applications of these models, right? Like, how do you apply some of these models for this? And these are now very, very general examples, which I want to talk about, and then tell you about how we have used it. Now, one of the things is, in your we have a deluge of data coming through, right? So one of them was surveys, which we talked about, which we can go, but we also have almost real-time data of people's travel. So this is, so if you use Google, right? If you have an Android phone, in your Android phone, you have something called location history. How many of you have seen that? Have you seen your location history? Yeah. So the location history tells you how you have traveled. It even tells you how much you have used your bike, how much you have used foot, how many trips on the vehicle. In fact, it can even tell you how many on the rail and bus. So it is giving you the percentage of your trips depending on the vehicle and also based on the distance. So for each individual, you can actually estimate your utility function, because this data is available. All right, and it can also tell you what your ODs are based on time of day. So from that, we can actually estimate origin destination of different regions. So we have done that for Hyderabad. You can do that for different regions. And once you do that, you can use it for modeling, because that is one of the pieces of the puzzle, is around mode choice, but also around the OD matrices. So I'll give you an example around one of the tools that we had developed for the US Department of Transport, which was called the Work Zone Impact Assessment Tool. Okay, so the problem there, the problem we were trying to solve was that you see this in India all the time, but also here in Australia, is there's always some construction happening on those roads. Either they are rehabilitating it or they're building a new road. So you're never able to get full capacity, right? So even if there are two parallel roads, they'll be working on it at the same time. So the question was, how do you schedule your works on the road network so that you have minimum impact? So once you have ODs, what you can do is run different schedules of working. So most of the time, what ends up happening is you say that you will only get it to work, we'll get people to work on those roads at night when there's less traffic, right? So that they finish the work in one night. So they need to be able to finish that work. So lot of these models are being used for that. It's being used for evacuation modeling and transport resiliency. We are using this for traffic operations, for basically being able to actually do traffic signal optimization, for eco signal optimization, where you're trying to reduce the emissions on your road network. In fact, what is interesting is that your signaling strategy is very different when it comes to eco signal versus delays. Because in eco signal, what you want is less fluctuation in your speeds. All right. And in this, you might not, so you don't want people accelerating and decelerating too many times. But when you're trying to reduce delays, it might make sense for people to stop for short periods of time and then go and then stop again. That won't work in eco signal optimization. Then we have been using it for integrated corridor management, where you have parallel routes. So how do you actually balance based on either tolling or signal optimization, variable speed limits? It is something I think the National Highway system should try to look at. And it's particularly useful for reducing the likelihood of crashes, because what it does is homogenizes the speed on your entire roads. Okay. So that's essentially telling you and we will talk about this tomorrow or day after, is around how we do highway safety modeling and doing the economics of that. So in these simulation models, there is something called surrogate safety assessment model. So in the micro simulation, you can actually get conflicts. And these surrogates are how hard did people decelerate how many times did people decelerate and where do they decelerate? How close did they come? There's something called post-encroachment time. And so you can use a lot of these surrogate tools to understand the likelihood of crashes. Right? Now, particularly from a demand perspective, why it has become more useful has been also looking at smart urban mobility services, which includes dynamic rideshare. So we have a lot of rideshare, but also the pricing around rideshare, where you have this surge pricing coming in. That is an important one. How do you set up your surge prices? How do you set up ride share services where you are able to actually get 2 or 3 people to use in one vehicle, and other car share services systems as well? So yeah, and with that, I'll kind of stop. Any questions so far?
No, sir.
So, Monica, which free tools can be used for better efficiency for big data? I do use a lot of Python and R for this. So Python and R are really good tools for doing this. And now with ChatGPT, you just put in that I want to do this analysis. It will give you some code, but it only does that for simple code. It doesn't do a good job at complex ones, even Grok as well, etc. Any other questions? Okay.
Sir, in chat, there is some question.
Yeah, so Monica is asking, uh, mm, uh, looking at road infrastructure planning models using AI. So I need to analyze using tools. So yeah, can you explain to me, Monica, if you're comfortable, would you be able to speak to this? Like, I'm happy to discuss, because I would need to understand a little bit more about. Okay, can you explain a little bit more about what your planning model is and what you mean by using AI for this? What type of AI are you looking at? But more broadly, R has good tools. Python has a lot of AI, inbuilt AI tools as well, like libraries. So if you're able to pick it up on Python, you can do a lot of this type of analysis pretty quickly. Any other questions? Okay. Sure thing, Monica. Absolutely.
So we will meet again at 2:30, sir.
2:30. Yep. So 2:30 would be 7 o'clock. Yes.
So I have class from 2 to 4, sir. So you
I'll
can.
be there. Yeah, I'll go through some of these examples and move it forward.
Okay,
Absolutely.
sir. Thank you, sir. Thank you so much.
Thank you. Thank you. Sorry? Okay. Thank you, Vikas. Thank you so much. Okay.
Okay, sir.
Vikas, can you check that? Can you able to manage the recording at least? So if you click the 3 dot points.
So, Vikas, I just shared the data set with you. What I was thinking we can do is we'll walk through the data, and I will also go through an easy way to do the analysis. I don't want to spend too much time on the coding. If you really want to do the coding, there's enough resources online to actually get the data as well. So we can discuss that. But I've shared it. If you can share it with the rest of the team, perhaps on WhatsApp or on email as well. So what you can do is download that data. Okay. Or you can just forward it also to them. So while you guys are doing that, so one of the things which I was just quickly look at the paper, and I think we can discuss the paper as well. It's an interesting paper. Okay, perfect. So what I'll do is I'll just share my screen. Can you share my screen? You see my screen?
Yes, sir.
Okay. So really interesting paper, Rahul. So I was kind of I just quickly took a look at it. So it's interesting from the fact that you can see this nice correlation, which you can see on the. Let me try to expand it. You can see this graph right here on the. You can see this graph. So one of the things which is you can see a nice negative correlation here between the gasoline pump price in a given year, average gasoline pump price across the country, and the annual road deaths per thing. So one of the important things about doing any kind of correlation analysis is the first thing to realize is, okay, there's a strong correlation. You can see that in the trend, but is that a cause? So causality is always a question. Are the annual road deaths lower because the gasoline pump price is lower? Or is there another reason why the gasoline pump price is lower, and because of that also the annual road deaths are lower? Because one of the things which might affect it is if I look at this correlation and I lower the make it higher, so does it happen? So the annual road deaths are reducing as the gas pump price is increasing. Yeah. So there could be a lot of reasons for that. So does that mean that by increasing the gas pump price, we will be improving safety? Is that what we can decipher? So there are multiple reasons, right? One could be that most of them are low income countries as well. So like Nigeria, Iran, I think even here, Egypt. There are some high GDP like Saudi and all of that, but on average, you have to look at the the road infrastructure, the GDP per population, the population, and the average speeds as well. So what they have done is they have actually done they have controlled for that. I'll think the next. So if you look at this regression model, they have actually controlled for the road deaths with as a function of gasoline price, GDP, population. They're looking at different years as well. So 2010 is year one, and you can see that they have compared different types of models. So GDP is also quite significant in all these models. So there are five different types of models, 6 different types of models they've compared. So this is basically called the p-value, and we'll go through this in our model, in our data as well. We'll go through this analysis. So if the p-value is low, that means these are significant variables. All right. So because they're significant, that means because they are significant, it means that GDP is also a big player in this. So in high GDP countries, you might have safer vehicles. You might have better roads. So there might be other correlations that might be affecting it. And in fact, my understanding is that they do that analysis. Actually, it's a good paper, very good paper, and worth reading. So that it's minus 0.3 to minus 0.6, which is significantly different than 0 as well. So yeah. So cool. All of you have got the data now?
Yes, sir.
Okay. So what we'll do is I'll go through the data. So I'm going to go through this as an example, and I think it goes back to a question of how do we get these data sets, right? So what we'll do is first we'll do a binary choice model where we have IDs, right? So these are called choice IDs, and we'll do a different model after that, which is a multinomial, but this is a choice IDs. So one way to think about it is different people have given their choices. So they have told that this person chose a car, which has this travel time, they have this travel cost, they've got this income, this age, gender, and this is their car ownership. So if you open the file called mode choice binary 1000, this is what you get. So it's telling you what mode they chose and what were the modal characteristics of that. So usually these are called revealed preference. So in revealed preference, say if I come and ask you what mode did you choose, you will say train. All right. Then what you'll do is give me the information on the train. So travel time, travel cost. Then I'll also ask you what is your income, what is your age, what is your gender, and do you have a car or not? Okay. So basically in a revealed choice, the only thing you will get is information of the choice that you selected. So I don't have information about the alternatives which you did not choose. Am I making sense?
Yes, sir.
Yeah. So because that's the only thing I observe, right, is what you have chosen and what was the travel time of that, etc. So I'll open the data set. This is basically the data set, right? So it's gender, car ownership, and it goes on. There are 1,000 people I have observed. I have made up this data, but it's based on simulation. So I've prepared this data. Now I want you to prepare a logit model. All right. So how many of you have ChatGPT readily? You can literally go online and do a ChatGPT. Okay, I'm just going to open up ChatGPT. I'll upload this file. Please prepare. Please. I'm trying to be nice to this ChatGPT, but all right. Hopefully this works. So before, what I would have actually asked you to do was I would have taught you how to code this on a statistical either on Python or on R. But you can easily find code to do this. It's not an issue. In fact, you can prepare your code in ChatGPT also to do that for R and this thing. So it's basically at the back end doing all of this. So what it'll do is, this is the IDs and this is the choices. It's going to prepare that in a while. So what it's essentially doing is it's doing a regression model, right? It's called a maximum likelihood estimation. So there are different ways of doing regression. One is doing a regression based on the fact that I'll take the log of this, right? The probabilities, I'll count the number of probabilities and I'll do a regression on that. The other one is called a maximum likelihood. The maximum likelihood is saying, what is the probability? I'm going to try to maximize the probability such that these betas, I'll estimate the betas, the parameters on this, such that my probability that I'll observe this data set is the maximum. That is called a maximum likelihood estimation. There's least square estimation and there's maximum likelihood estimation. So generally, this one does a maximum likelihood estimation. So let it run. Have you all been able to do this so far, what I'm showing you? Hello? Yeah, have you been able to try that?
Yeah.
It's taking its time.
Yes. Actually, sir, I do on Copilot. It is okay.
Oh yeah, use Copilot. It doesn't have to be chat. Use whatever, and we can also test out if you've got similar results.
Okay.
It's taking a while. I actually ran this model, and I have the results. So this is how the results would look like, but we'll talk about that. Okay, so my model has run, and I can. So this is based on. I think it has only used the first whatever 50 rows data set. But has all of your models converged?
Yes, sir. It is run, but the final result will be different for the Copilot and ChatGPT.
Okay, no problem, but at least we can see, look at the results, right? So you can literally, what it's basically doing, it's doing a regression model, and it's able to give you the coefficients. Okay.
Okay.
So what my instance did was it took the top 20 by log odds. Okay. So these are the coefficients. So but it doesn't, it only tells me the odd ratios on the what's it called, on the variables. It has not given me a constant value. So this has been an intercept as well. So if you look at this is, I actually coded it up and prepared it. The coefficient here for car ownership was plus 2.689. Here also it's coming around the same, plus 2.689. Gender was 0.2168. Gender was 0.217. Age was minus 0.027. So this is coming out to be very similar. All right. So at least what I can say is that the generative AI is doing a similar estimation on the models. All right. It's always good to test and check and evaluate it. Now, what does this mean? Have any of you ever seen the results like this? Do you know how to read this data set? This results. Hello? Straight up.
Yes, sir. I know, sir.
Okay, so basically what this is telling me is that this is equal to, the utility is equal to minus 0.63 plus, or no, minus 0.066 multiplied by travel time minus 0.158 multiplied by travel cost plus 0.00010 multiplied by income plus minus 0.0227 multiplied by age plus 0.217 multiplied by gender and plus 2.689 multiplied by ownership. I'm just calling it CO. So this is my utility model. All right. This is my intercept. So given this utility, I can tell you what they would choose. It's a binary logic model, right? So this would look like the probability of choosing. Let's do this. So the probability of choosing an alternative A is equal to e raised to power exponent of V divided by 1 plus exponent of V. That's it. That's basically what how you would be solving for the probabilities. This is it. That's how it has been. That's how you've got these results. Now to read this, now this is what this is telling me. Now, how do we know that which variables are important and which variables are not important? Okay. So for that, what we generally do is look at something called the Z value or the P value. P value gives you a good result, like a good understanding. If my P value is less than 0.05, which is at a 95%, what it's telling you is it is significantly different than 0. So like this one, P value is 0.46, right? So, and what it's telling me is that actually, even though this coefficient is minus 0.63, it is close to 0. All right, there is a probability of the probability of it being close to 0 is almost 46%. That 0 lies within this. So this intercept is not an important variable which will tell you what is really happening, but travel time is. Travel cost is. Oh no, travel cost is also not significant actually. 0.37. Travel cost has not come out to be significant. Income is not income is significant. Age is age is also significant, but gender is insignificant, and car ownership is significant. All right. So this is how we would interpret this from a modeling standpoint. Now, one question which is always asked is, what is the value of time? So value of time is nothing but the coefficient of the travel time, that is minus 0.066 divided by the travel cost, the coefficient of the travel cost, that is minus 0.15. And we have to, of course, make sure that the travel time units and all of that are appropriate. So this will come out to be, just making a quick. Oh, sorry, it's the other way around actually. Apologies. It should be the coefficient LP that's rupees, whatever, 2 rupees, 2.38 dollars per minute or whatever. I had not put in any value, put in actual units, but this is essentially how we interpret and make sense of all of this data. Does that make sense so far? Any questions? I might be.
So always, sir, we have posted this data to programming language, or there is the use of Dixit.
So traditionally, I used to use a lot of usually I use you can use MATLAB, you can use Stata, you can use SPSS, you can use R, you can use Python. So in Python, you can literally give data set, and there are libraries which you say, please, not please, but logit model. So you literally have a logit, and you give the utility function, and it estimates the parameters. Does that make sense, Manish? So that's pretty much how we do it. Now, with Copilot, Grok, and all of this, you literally upload the data, and it gives you an it's not perfect as yet, but it is giving reasonable results.
Sir, if possible, can you please show any coding with is how we can write that data? Actually, I also learn Python currently.
Okay. So
I know the basic of data sets, is how we can upload the data and how can the output will come from the Python. But
it will look exactly like this. Actually, to be honest, I'll show you. It looks exactly like this. The results. So I can give you where's the so this there is a literally it's telling you what it did, right? Auto detected the dependent variable, which is a choice. Hot coded the categorical, that's okay, and split stratified. Then there's a logistics regression model. So if you go to there is a library called scikit-learn logistic regression.
Okay.
In Python, let's just go. Python library. Yep, this is it, right? And there are some examples usually here, like here.
Okay.
Right, and in all of these you have to actually give a utility function. What are you the regression function on what you're actually regressing on? So you have to give your x's and you have to give your y.
Along this question, I have one more question, sir. I think it is not for the transport economics, but when we are finding the ODPS, we also calculate the attraction and production of particular zone to input that data to the visual. So in that point, we also use this library for getting the output, or there will be any another procedure to follow.
Can you say that again? Sorry.
Uh, uh, Actually, this question is not a transport economics point of view. Actually, I
No,
asked this
that's okay.
question.
It's a modeling
Okay.
question.
Yes, yes. Actually, I do the modeling on Visum software. That time I required the attraction and production data on particular zone. So that time we have calculated that data from trip generation and trip model from individual zone wise. After that, we have coding. Actually, I learn of that part. Currently, I not get that much idea about the Python coding. I have a question. This library that we have show right now, this is also applicable for this finding the ODPX for attraction and production, or there will be another method to follow.
So no, I'm not covering attraction and production in this particular class,
Yes.
but the way you would actually go about it, right? So you're basically doing a gravity model. And generally, when you do a lot of this, is gravity model.
Yeah.
Now, you can actually use, based on data, you can actually develop. So you'll have origin attraction, like based on attraction and production and attraction zones. And you can actually do a regression model. So if you have data on the number of trips, the production, attraction, etc., you can actually do a regression model on that based on gravity model. You can literally put in the data into this and it does it. And that one is a simple nonlinear regression model.
Okay. Okay. Got it.
So instead of actually coding it out and all, I still prefer to code it because my trust in the system is not perfect as yet. So I always like to code it and then I test it out. But yeah, it's doing pretty well. So a good thing. One second, So a good thing about this is it's literally telling you what it has done, and then it used stat models logit for creating the full coefficient summary, which was this. This is the coefficient summary. And this is telling you like what are the R squares, etc. Right? Any questions so far? Is it making sense? So there are three important concepts. One is the idea of a revealed preference data. In a revealed preference data, when a person makes a choice, the only thing you have is the data on that choice. So for every person, you'll have a different row, right? That is number one. Number two is I showed you how you can actually regress on the model. I've not shown you the Python code and all of that. You can actually learn that. It's a totally different, it's a full, probably it's a 2-3 hour course on just going through that and setting it up. And it's very easy. Like you can literally online you can get a lot of these codes already available. In fact, I put up a lot of this code as well. Then what else? The other thing is we kind of discussed how to interpret these statistical results, right? The idea that what do these coefficients mean? It gives you the utility function. Then whether these coefficients are important or not depends on the p-value. If the p-value is less than 0.05, like this case, like this case, this case, this case, they're significant. And the final thing was around the value of time. $4 an hour. So for every travel time saved, what is the value of time? So similarly, you can have value of reliability also. So if you put reliability, standard deviation of travel time, you can get value of reliability. And exactly this, take the cost, divide that by take the coefficient of the cost and divide that by the coefficient of the standard deviation. Any questions so far? And you can try to play around with it, try to play around. And in fact, one of the things about it is I can show you even in Copilot. How many of you use it like this? Have you ever used it like this to estimate models and all of that? Okay, good. You can in fact generate the Python code. Right. I will. You can check it out with us. Give it a couple of minutes. So this is it's creating the code. Just give it a minute or so. Or probably I've broken ChatGPT right now. Any other questions so far? So more broadly, I think I've kind of shared the main principles and concepts here. So the next one I want to do, let's see if it has kind of prepared that. It's still thinking. Let it think when it sets it up. The third one, the second data set I created was more called a stated preference survey, right? So what the stated preference survey is basically each person gives you different, provides multiple responses, right? It can be, or you're actually creating a travel diary. So you have that for different trips. And I'm also going to do a multinomial choice model, which is basically looking at 1, 2, 3, 4, 5, 6. So 6 alternatives. So let's look at the data. So it has a lot of information here, right? This is basically telling you, is giving you the, when I was simulating it, this is giving you the utility function as well. So, but that's, we'll get through that in a moment. So the person chose car for the first one, and we have the time of day, distance, IVTT, and all of that information here, right? And this is giving the utility here. So it's chosen a car. It's bus, train, bike, walk, ride hail. And same here. So what it is giving you is, it's for this person, it is giving you, for this respondent one, it is giving you the utility function, utilities for each of the, need to open it up a bit more. Each of the 6 choices. All right, so for this person, they chose car. And if you look at it, car has the highest utility. No, actually, this one has the highest utility, which is bike. But because it is a logit model, it puts a probability. So this is gotten car. If we look at this one has got, this one has, they have used train. But on average, what you'll find is people tend to choose based on the utility. The proportionality is based on the utility. So even though you might have the maximum utility, there is a certain probability. So it will be e raised to power minus 1.0 divided by e raised to power minus 1, e raised to power minus 2. So you add them all up, right? That's how you actually end up getting your probabilities. Any questions? Am I making sense so far? Just kind of sharing the data. This also has information about the demographics, right? The purpose of the trip, the time of days. And then this has information about the trip, the type of trip.
So, sorry, sir. This data is our final output, right?
When you say final output, what do you mean by final output?
Means when we have got a survey in a format of OD,
Yeah,
origin destination, right? So in that format, we are only know the where the car will be come and where will be go, and which type of mode choice they are using, right? Accordingly, on that base data, we have modify into this as a final output. Or
so
there will
that,
be,
yeah, so this one would be more like your OD surveys, right?
okay.
So this one would be more like an OD survey, because what it is telling, for each person, you would have gotten information about whether they chose a car or a bus, and what is the travel time, what is the travel cost, income, age, gender. This guy chose a bus. So it will basically look like this when you do your OD surveys. This is called a stated preference survey, not this one. Sorry. Okay. Yeah, this one is called a stated preference survey. So what I do is I give them a choice between the different mode types. So I'll show them a car and I'll tell them that, look, this is the travel time in car. This is the travel time in bus. This is the travel time in train. This is the travel time in a bike. And this is the travel time while walking. This is the amount of time you'll have to wait. So in walking and bike, you won't have to wait. In a train and bus, you'll have to wait. In a car, you don't have to wait. This is the access in minutes. How long does it take to access it? So if you're walking, you just walk, right? So you don't have to, it doesn't take long to access the mode of walking. Bike, it takes less. Car, it takes less, but it might take longer to access bus and train. How many transfers? So they have, if you take a train, you need to transfer. Is there crowding or not? So on the train, there is more crowding, like in Bombay. And what is the cost? So what you're doing is you're providing the user all this information, right, on a table, and you say which one would you choose? So it's very similar to this. So if I tell you, look, this is the data. Based on this information, we will actually show it in a much prettier way. But based on this information, which one will you choose? And you will say car. So this is how this survey data is created. This data is created. For the second person, I'll ask similar, these next 6. Which one would you choose? And then you would say, I will choose a bus. Then so on and so forth. Does that make sense? This is how the data is generated through an experiment.
Okay, so
Through a travel survey.
in case we have any means how we can check this data is properly means is correct or not, in any checks or any method to know means we got a data from this chat GPT, we can proceed further, but in certain point
No.
we also.
Yeah, so the chat GPT data is not the right data. You have to actually go out and do a survey.
Okay.
This data is something I have simulated. This is not
Okay.
generated. So this is not something I generated through chat GPT.
Okay.
This is something I simulated based on Python, and I said, look, this is the utility function of a car. This is the utility function of a bus, train, cycle, and all of that. So this is how it would look like.
Okay, sir.
Does that make sense? So I generated that through a simulation. So in real life, how you would create that is through a stated preference survey. You would actually be showing them. You would be giving them this choice. I will be showing you these 6 choices, and I'll ask you which one would you choose, man? And from that, then I would estimate the utility. Utility is not something I observe, right?
Okay, sir. Yeah,
Got it?
got it, got it.
Maybe I might just delete it. Let's delete that. Okay. Let's go. Okay. Now I have to again create that. Create the multinomial choice model, right? So what we'll do is we'll do a similar step. Let's hope this time it works with this. There is let's open this. It created a lot of Python code for that. It should. Okay. What's not? It's having a problem. Doesn't matter. So the next step is doing a I think is the final. So it's going to now estimate a multinomial choice model for this. So I had run that model before. So, and this is how the results look. All right. So let me explain to you now what these results look. So what is it? What is ASC underscore byte? It is an ASC stands for an attribute specific constant. So remember, like when we were doing the utility function, every, like if we go back here, we had a constant, right? This part, right? This 0.63 was a constant. So every mode has a constant. So bike has a constant of minus 1.9, bus has a constant of minus 2.2, ride hail has a constant of minus 0.91, train has a minus 2.0, and walk has minus 2.5957. Do you notice that there's something missing? What do you think is missing?
Gender or age?
No, but there's one of the modes are missing, right?
Yeah.
Car. So you
Car,
don't
yeah.
have an ASC for car. So usually what happens is whenever you do this multinomial logit model, if you have five modes, you will only get four. You'll make one of them zero. You'll make the constant of one of them zero, and you'll find the other four. So that's what's happened. So the attribute specific constant for car is taken to be zero. Okay. And so what it is basically saying is, compared to a car, people prefer not to take bike on, right? Because it's negative compared to a car. People prefer not to take a bus, are less likely to take a bus. So just by looking at all these, you can see that most of them are negative. But one thing you'll find is that ride hail is minus 0.91. And if I look at the p-value here, it is greater than 0.05, correct? So it is close to zero. So the difference between the attribute specific constant of between a ride hail and a car is very similar. The rest all are different. That is the first thing to interpret is the attribute specific constant. Does that make sense? How we are evaluating this?
Yeah, sir. Yeah. Little bit confusing, but okay.
So tell me, what is the confusion?
Actually, sir, can you go that slide?
Yeah. Oh, let me also see if the model is still analyzing. It's taking its time. So let's let it do its thing. Yeah. Tell me. only look at the first thing is only look at the first 1 to 5. I'm only talking about the variables 1 to 5. So do you want me, what's the question?
Can you
It's
please
not
repeat?
making sense.
Miss, it's it मुझे थोड़ा समझ में थोड़ा डिफिकल्ट जाता है इस लेक्चर में।
हाँ नहीं कोई नहीं, तो मतलब तो प्रॉब्लम आपकी नहीं मेरी है, मैंने ढंग से समझाया नहीं है इसका मतलब। नहीं पर तो आपको कहाँ पे नहीं समझ में आ रहा?
Actually, this point when we got a final result, it is directly come from the coding, or there will be any formula that we have put in to get this result?
Good one. So yes, we have to put in a. So remember when this morning, let me see if I've got my presentation. Let me see if I've got. Remember when I showed you this?
Oh, yes.
I have to put a formula. I have to put this utility function.
Okay.
And it is a linear one. So पहले मैं बोलूँगा कि मेरा और फॉर्मूला में मुझे बस ये बताना है कि मुझे नहीं पता ये एक वेरिएबल है अल्फा. I don't know. So there's a bias called alpha. All right.
Okay.
Then there are parameters called beta, which are coefficients to this cost. So it's like when you do a linear regression model, you have all these data, but you don't know the parameters, right? You're estimating the parameters, but you have to say that it is linear. That's literally what we are doing. We say that this utility function is linear to all of this, but I don't know what my betas are, what alphas are, and what gammas are.
Okay.
And I also give this, that it is a logit model. It's a multinomial logit model. So what I say is, it is this. I give this equation as well. All right?
Yes, sir.
So these are the formulas that have to be put in. So it is going, when you do the coding, I'm not doing the coding in this, right? Like, so it has run the model. Actually, it's a different one. Huh? What happened? So okay. Let me try this other one. Sorry, give me 1 second. Give me 1 second. Okay. Let's upload this again. Let that run. So going back to this, so this is the equation I'll have to give, but I'll also have to give an equation for the V's, which is basically this. So what I'm estimating is alphas, betas, and gammas. So alpha is the constant, which is called ASC. Betas and gammas is something I'll show you, which are the gammas and which are the betas. Okay? So that's a good point. तो मैंने ढंग से समझाया नहीं था, तो अच्छा हुआ आपने प्रश्न पूछा. Is it making sense what I just said or नहीं?
नहीं समझा भी sir. It's got it.
Got it or no?
Yes, sir. Got it.
Oh, okay. So let's go back here. So like let's look at only bike. ठीक है, तो बाइक में ये है कांस्टेंट टर्म -1.9. फिर हमें एक और चीज पता है कि जो सारा इसमें वी डोंट आई हैव नॉट पुट एनी क्या नाम है एनी डेमोग्राफिक का डेटा इसमें डाला. इस मॉडल में मैंने डेमोग्राफिक डाला नहीं है, डेमोग्राफिक पैरामीटर्स. But what I have is betas, which is basically associated to in-vehicle travel time, weight, access, transfers, crowding, cost, parking. So all of these are the parameter, the coefficients will be the same across bike, bus, ride hail, train, and walk, and car. Okay, these will be the same. The betas will be the same, but the constants are different. Okay, that's number one. Number two, the point I was trying to make was, अगर यहां पे देखोगे आप तो कार का नहीं है, कार का कांस्टेंट नहीं दिख रहा आपको. Yes.
Yes.
So usually, because usually what we do is, एक सेकंड दीजिए, एक सेकंड दीजिए. So what we generally do is we take one of the modes and put their constant to be equal to 0, and the constants of everything else is in relation to that. Are you getting that point?
Yeah. Yes.
So the car का जो constant है, that is 0. Now what it is saying is that people are less likely to choose bike because it is negative and it is significant. -1.9 is significantly different than 0. But here ride hail is -0.91. Is close to 0, so that people don't really have any attribute specific preference between ride hail and car, but they do have between bus and car, bike and car. Making sense?
Yes, sir.
Okay, so that is number one. So there are 2 points which we made. Okay, one is putting the formula and the second is the ASC. The second piece is, again, now you have all these parameters. You can kind of look at which ones are going to be significant, which ones are not. So the ones which are significant is bike ka, the constant, bus ka constant, ride hail ka it's not significant, train ka significant hai, walk ka significant hai, in vehicle travel time. So matlab the travel time while you're inside the vehicle, that is significant and negative. Cost is negative. So the way to find value of time is again 0.17 divided by 0.03. That's roughly around, like, let's say 18 divided by 3, or let's say 17 divided by 4. Right? So it's around 4 point something. 4.1 rupees per minute, per 10 minutes or per hour. Right? Weight is not significant. Access, time spent to access the mode is not significant. Transfers are significant. The fact that you have to transfer makes a difference, and a negative difference. Crowding is not significant. Costs and parking costs are significant. So this is how you would interpret it. Let me see if my network connection was lost. I've also been running it on a different instance, so let's see if that works. Any questions so far?
No, sir.
What about for the rest of the team? Let me try to see if I can find the other instance where I ran the model. Give me a moment. Has anyone's else's model converged for the multinomial logit model? Okay. What is, can you put it in this thing? Is it similar to what I found? Bit different or very different? Okay. Yeah. So that generally happens when you're using different tools. So yeah, so that's okay. That's good. What did you use? Did you use ChatGPT or did you use? Okay. Now, what will be interesting to do in this is try to see if you can do a nested logit model. Because if you look at it, there is three types of different types of mode, right? Car and ride hail together, bus and train together, bike and walk.
Sorry, sir. Are you sharing your screen?
No. I'm not sharing my screen.
Okay.
I'm
Okay.
just I'm
Okay.
talking right now. Sorry. So I'll share my screen as well. Sorry. I'll go back to my slides. So let's go back to this, right? Now let's look at the different modes. So we did a multinomial logit model. Now, what is the problem with multinomial logit model? We talked about that, correct? What was it? That all the modes in the multinomial logit model are independent, correct? But we know that bus and train are public transit. So we should try to nest them together. Car and ride hail need to be nested together because they are similar. Bike and walk are active transport. So we might need to nest them together. So one way to do this, and this is pretty much what we do as well, is we run the model with different specifications. So what we'll say is that please run a nested we run a nested logit model where we have to explicitly say that the nest is car ride hail in brackets, bus train in brackets, and bike and walk. So I'll try to do that. Let me see if it has run. So it's still running. It's just because I made changes. Let's try that. I'll have to. It's causing. So the way I would actually run this in ChatGPT is create a nested model with the following car right here. Bus, train, and bike, walk. I don't know if this will work. I'm having issues anyway with. Yeah. Okay, so let it run, and you can try it yourself as well. And you should find different results. And the way you generally test the performance of these results is by looking at their R square, their ASCE ASCE estimators. There are some statistical estimators which you need to compare. Any questions? I know it's quite an intense and a bit hard to do this online, but it's a bit intense. Is it making sense?
Yes.
Yes.
All right, excellent. And you know, I was telling somebody, my colleague, don't feel guilty when you're using ChatGPT or Grok or any of these things. These are really useful tools, but do not trust it. Do not trust it. Take your time, try to analyze, do it yourself, do it with this thing, because it's in its early stages, and it's still not stable. When I was graduating, I remember this. Google, when it came out, the Google search, before, we used to go to the library, and when Google came, the same kind of hype was there. Oh, people will not know how to use a library, and uh, how will they read books? They'll stop reading books. And it was a very useful tool. Google helped or the search engines actually helped put things together. So don't feel guilty or feel bad about using these. Try it. I think we have broken ChatGPT. At least I have broken it for myself. But yeah, this is the results I found when I ran my code. In these early stages, people tend to this thing, but use it, try to find where it breaks, and it's good. It's a useful tool. Any other questions or comments? Just noticed.
Sir, no question.
No questions. That's all I have for today. In terms of the tutorial around demand. I know we were planning to do costs today, but I think it made more sense to actually go through the lecture of demand and then do the demand models. So one of the things I found is it at the moment. Yeah, sorry, go ahead.
Sir, do you have any one more example regarding that you can share with us so we can go through it? Any dummy data example that you have?
So would you like me to send a dummy data example for? So I've not created one. So I basically created two. One was a binary logit and then a multinomial logit. And I can do one more on nested logit, but it'll take me time. But I'll prepare that. Perhaps we can talk about it tomorrow morning before we start. But yeah, I'll do an example of a nested logit.
Yes, sir. Thank you, sir. It is helpful to us.
Yeah, no, I'll do that. I'll give you the results because I don't want to go through the coding in this thing, but I'll like I showed you this data. I'll take this data and I'll run a nested logit model. This. All right, perfect. Thank you so much and have a good evening, all of you. Thank you.
Thank you, sir. Thank you.